Okay, so good morning, everyone. Welcome to all who have joined. I've seen about 50 participants so far. So this is the Behavioral Sciences Statistics Clinic. We are going to provide you with a refresher on using statistics in research. So this morning, I would first like to welcome Dr. Esnad, the head of department, and she will give you some welcome remarks. Dr. Esnad, you can take the floor.
Thank you, Dr. Addison. Thank you, colleagues who are here with us this morning, and also everyone who has joined us this far on this very early Saturday morning, for which most of us would take for rest and other activities. I'm quite delighted and very encouraged to see that at least 50 of you all have joined this far and really showing interest in what we are doing today, which is really an inaugural start of something that is very necessary in the department. I believe not just for us, but for all persons within the Faculty of Social Sciences. The intention of the Behavioral Science Statistics Clinic, and with a very nice acronym of BSSC, and we will hold on to that, is really about promoting the use of statistics in the course of doing research and understanding the relevance of that type of analysis in the process of understanding data and really speaking through trends that exist within that data. It is so very important, and we have noticed that over the last 3 or so years, and that's encouraging, and this is not to say that this is not encouraging, but just to show you a pattern, that there have been a movement in our department, certainly, towards more qualitative studies coming out of the MSc in particular, and still a very strong hold with the quantitative at the MPhil PhD level. But we've also noticed that there's a phobia, for lack of a better word, about the use of statistics in research by the students who are currently in the department and doing graduate programs. I think this could certainly extend to undergraduate students who, while they have to do introductory statistics and they also have to do survey design and analysis, which allows them to apply the statistics that they would have learned in the first year, we have gotten a clear sense that the students do not have the confidence and the efficacy in their ability to do statistics and to use it comfortably in order for them to understand the phenomenon that they are investigating at that point, and to speak to not just the trends, but possible predictions that can be made based on these trends that have been observed through the data. The beauty about statistics is really the ability to capture the grand picture, to allow us to see patterns in the data, and obviously to make predictions about what can possibly unfold within that context and within the scenario that we are trying to understand. I would like to share with you, if I may, just for about a minute, of work that we are doing to really understand the current challenge that we are facing around the use of statistics. And it's really important. As researchers, we are trained to do research fundamentally. And what we have done over the last 3 years with the assistance and support and collaboration, I think it's more of a collaboration with Ms. Farida Aladdin and Ms. Kisha Samlal, we have really tried to understand why is it that students have this phobia towards the use of statistics and in applying it to do research. And over the last 3 years, we've undertaken research with undergraduate students in first year, trying to really get a sense of how competent they are in the use of statistics and whether they have a fear about the application of statistics, or even whether there's a level of efficacy in the ability to use statistics. And what we have found is that yes, the fear exists. Yes, there's a level of concern among the students that they are not able to really effectively and with a level of comfort engage in the use of statistics. But more interestingly, we have learned that the fear is built by the presence of the teacher, the instructors, by their past engagement with the mathematics teachers, how they have learned about statistics through those classrooms, and the lack of confidence that is built based on that engagement in the classroom at the secondary and at the tertiary level. And certainly what it has told us is that when you speak about statistics, it's not just a technical process. It's not just about calculating and drawing numbers and really using a test to be able to have a statistic in your hand and interpret that. it's also about building the confidence. It's about the words. It's about the meanings that you give to the statistics. So when you think about statistics, you have to think of it in both qualitative and quantitative terms. Very interesting, right? So that what we have gathered thus far is that statistics, yes, it's a technical process, but how we teach it, the context for which we build confidence in the ability to use it is also critical. This morning's session on the use of statistics, and as we have carved it in terms of the Behavioral Sciences Statistics Clinic, is one step towards addressing these issues. And as researchers, there's nothing more logical than using that data and that research to build on the teaching of statistics in the department. And this is what this particular statistical clinic is here to do today. So this clinic is based on research, is based on our findings of how we need to promote the use of statistics, but how we need to encourage students to feel comfortable to know what statistics can be used for, and then to apply them in the use of their own research. And I kid you not when I say that while you may not need this for your undergraduate degree, or you may not need it for your MSc for persons or MPhil PhD persons who decide to do qualitative, somewhere down the line, whether it be at your place of work or in a potential consultancy, there will be some request and some need to know basic statistics that allow for you to do basic statistical functioning. So I would like to really welcome all of you here this morning. I want you to really, I want to commend you for your presence here, because this is the step in the right direction. And I want to reassure you that this is not going to be a one-off clinic being offered by us. We are going to do another round of this next year and follow up in the next semester with a workshop for graduate students. This is the first, but certainly not the last. I welcome every one of you this morning. And I also want to congratulate our facilitators, Dr. Addison, Ms. Farina Aladdin, Ms. Keisha Samlal, and Ms. Dilia Brito. This is a collaboration between sociology and psychology facilitators / lecturers / instructors. Welcome, congratulations, and I wish you all the best for this morning. Thank you.
Thank you very, very much, Dr. Esnad, for those remarks. And I reiterate the fact that we really need to have a move towards marrying the qualitative and quantitative aspects, just to be able to, as I like to tell my class, to tell a story with statistics. So we really, really appreciate your kind words and sentiments for our segments today. So just to jump into the introductory remarks based on how we will move into each of the modules, I just wanted to give you all a little bit of a picture of how you probably started off, right? One does not simply understand statistics. I am hoping by this point that most of you can say otherwise, and that by the end of this session, we may be able to kind of grasp concepts in a different way, where we will be able to use statistics, even in joke form, even in memes. I really enjoy statistics memes myself. I'm a bit of a nerd. And what we really want to do today from beginning to end is really to tailor the conversation towards taking that data that you would have acquired and building a report with that, because that is of importance to you, building that story. So you would have the technical skills already from the different courses that you are in, but we want you to be able to see how it actually generates something that's meaningful for your particular field. So the agenda today, we actually have it broken down into 4 segments, followed by a question and answer. So we have 2 first segments about surveys and coding, and then exploratory analysis. And then we will have a short break, 15-minute break, followed by the 3rd and 4th segments with inferential statistics, and then some results and interpretations. Now, what I will caution is that we would not take questions in between unless there is time in between these segments. I can take a burning question, but I encourage all of you, please place your questions in the chat. And we actually have a segment for a short question and answer at the end, which follows all the segments. But if we finish before in terms of a particular segment, we could actually address the questions one time. So as the speakers go on, feel free to place your questions in the chat, and we'll moderate the chat and compile all the questions so we could actually have a really fruitful discussion. And just to introduce our team today, well, we already have our esteemed Dr. Esnad, who is the head of Department of Behavioral Sciences, and she's also a sociologist, as you know, and she's the coordinator of the introductory statistics courses for behavioral sciences. And these are her research interests in terms of women, work, and organizations. And I think all of our team has their videos on right now. So I'll just call them each one. If you want to see a quick welcome, Miss Farina Aladdin. A lot of you will know her from the SOCI 1005 Introductory Statistics for Behavioral Sciences, and she also does survey design and analysis. Farina, if you want to say hi, you can give them a quick hello.
Morning, everyone. Thank you for being here.
And then we have Miss Keisha Samlal. She is a teaching assistant with the sociology unit, and she also teaches the introductory statistics for behavioral sciences. So Keisha is on video as well. She'll say a quick hi to everyone.
Hi, morning, everyone. Looking forward to the session.
Then we have Miss Delia Brito. She's a part-time assistant lecturer for the Psych 2010 course, Statistics and Research Design in Psychology. Delia.
Good morning to everyone, and a warm welcome to you all.
And last but not least, yours truly, I am Dr. Addison. I'm a project officer at the University Office of Planning, and I'm also a part-time lecturer for the Psych 6-13, which is the Advanced Statistics and Research Methods course. And I would like to say I'm very, very happy and excited to be part of this team and to welcome you all to this session. So I'm really giving you all the positive vibes that we're going to have a great session today, regardless of the fact that we are all virtual and can't see each other. We'll make it very interactive. So just to remind persons who did not fill out the icebreaker survey, the pre-survey, please do so. It's the form, I have the link there, but the link is actually in the chat as well. So please fill that out, because what we will do is before the end of the first two segments, we will actually give you all an idea of what the general responses were based on that survey. So we'd be really happy if you all would be able to do that for us as soon as possible. So without further ado, let us get started with our segments. So the first segment, Ms. Farina Aladdin and Ms. Keisha Samlal, I will give you the floor. So I will stop sharing my screen. So Farina and Keisha, feel free to jump in when ready.
Hey, so good morning, everyone. Again, welcome to the session. We'd like to start off today's session with taking a look at your questionnaires. And before you even think about coding, before you even think about data analysis, before you even think about, what am I going to do with this data? You have to ask yourself, what is the data I'm trying to capture? And this is where your questionnaire comes into play. So your questionnaire is your data collection tool. It is what you're going to use to capture all the information about your variables. But before you even think about that as well, you also have to situate your questionnaire as part of your research process. So before you begin formatting your questionnaire, crafting your questions, thinking about how you're going to word your questions, you have to be sure about a couple things. Firstly, what are the variables that I'm interested in investigating here? What are my independent and dependent variables? And this requires you to take a couple steps before. That is, you should have done an extensive and thorough literature review on the topic that you're interested in. You should have made some kind of consideration around a theory or a conceptual framework that helps you to guide your understanding of how these variables might interact or impact on each other. And you should also have had your hypotheses worded. So it gives you a sense of, okay, this is what I'm going to investigate about these variables I've decided upon. And in order to investigate these things and to go further and test these, I need to capture specific types of data about these variables as well. And so all of these things need to be taken into consideration when you think about formatting your questionnaire itself. So on the screen, we actually have an example of a questionnaire, and this would actually be the icebreaker survey that you all are currently looking at. We've asked a couple of you to do this survey, but on this itself, you would see that we have a number of questions. So Ms. Alden, if you could scroll down, please. Thank you. Right, so we have a number of different questions around different variables. For example, we have sex as a possible demographic variable. We have questions about age. If you scroll down further, you would see we also have questions about your student status and degree program. And what each of these questions are doing is it's capturing different types of information about these specific things as variables. So if you have your degree program as a variable, what we're trying to capture here is which program do you belong to? And that is information. That is a particular type of information. When we talk about types of information, what we're referring to are the levels of measurement. And I believe most of you here have done some kind of introductory statistics course. I know we have one or two who may not have. So I'll just break this down a little further. When we talk about levels of measurement, we're talking about the amount of detail that we're trying to capture or trying to collect about a specific variable. And the detail really translates into, firstly, the quality of the data, and then what you could then go on to do with the data. And so we will be referring to levels of measurement throughout our session today. But firstly, I'd like to remind you that there are 4 levels of measurement. You have nominal, ordinal, interval, and ratio. Your nominal and ordinal levels of measurement are what we could safely refer to as categorical data. This is mostly variables where you cannot really get a sense of any kind of numeric understanding, any kind of numeric distance, or you cannot necessarily quantify this variable, but you can get a sense of how your sample or your population fits into the different categories of these variables. So for example, if we look at question 3 on our screen, it says to please indicate your student status. So I cannot quantify student status. I cannot say student status 1, 2, or 3 and get a sense of what that means. But what I can do is I could provide options such as categories that tells me how many of my sample persons belong to an undergraduate status, how many belong to postgraduate, and how many belong to qualifying status, right? And what that tells me then is how persons fit within the categories of how we may understand the variable itself. So your nominal and your ordinal levels of measurement are the questions that you will put onto your questionnaire that really captures that categorical type of data. And this lends itself well to more descriptive types of analyses, where you simply want to understand how your data set and your sample is distributed into different groupings and categories. Beyond that, now we also have what would be considered the more numeric measures, the more quantitative measures, in that we're actually capturing now numbers, and these numbers are meaningful to us. And this would be at the interval or ratio levels of data. So your interval and ratio levels of data, this is where the numbers actually mean something. So for example, on the screen, we would have the question regarding your age. If someone tells you their age, the number that they tell you is meaningful to you. It's the actual number of years around this person's age. So someone who is 18 years old, they've lived in this world for 18 years. Someone who's 50 years old, they've lived in this world for 50 years. That number is meaningful. And so interval and ratio level data, or interval or ratio level questions on your questionnaire, what it does is it captures that numeric data that is meaningful to you. Now, your interval level data tends to capture information that are grouped. So you have ranges of information, as we have here. And, you know, as part of it, you will be consistent in maintaining your ranges as part of your question. And you would try to ensure that the data that you're capturing is one that is useful for you, not only for descriptive, but for inferential statistics. Also, we have ratio level data, and a big part of ratio level data is the presence of that 0. So unlike the interval level, the ratio is the one that makes use of that meaningful 0, meaning that there's no use, there's nothing If you say you have $0, you have $0, right? So you have to think about the nature of your variable as well. Is this a variable where the 0 is meaningful to me? Is this a variable where the 0 means absolutely nothing? And so when you are crafting your questions, this is why it's important to firstly know all about your variables, which is where your literature review comes in very helpful. And it's also important to know what you want to capture about these variables, what data you want to collect, because then it guides you into how much detail you need to have for these particular variables. So do I use a nominal, ordinal level of measurement for this variable? Do I measure income as just low income, middle income, high income? Or do I need to know actual amounts of person's income? So that means I would actually need to take the data to the interval or ratio level. All right. So this is where your hypotheses will play a very strong role in determining how you will craft your questionnaire itself. Now, once you've taken the time to carefully put together your questionnaire, you've constantly made reference to your literature review, you've constantly made reference to your hypotheses, you've carefully ensured all your variables are present on the questionnaire and the right levels of measurements are in place, you then go through the process of disseminating these questionnaires to your sample and collecting the data. You've collected this data now, depending on your sample size, maybe you have about, I don't know, 100, 200 questionnaires. What do I then do with this data? It could be a bit overwhelming, all right? You have this fat stack of questionnaires, all this data you have to process. You can't just flip through all of these questionnaires and get a sense of what is happening, all right? You need to then enter into a process of thinking about preparing this data for analysis. And this actually brings us now to how we think about preparing these questionnaires. So for persons who may actually be using physical questionnaires, a very useful tip to you would be to number your response options, because that makes it easier for you to prepare the data. This data, for as part of your analysis, what you're going to actually do is step into thinking about how I'm entering this into my program. So most of us, we would use programs such as SPSS and other similar programs, but it doesn't just translate into you have this data and then you move into SPSS. You have to actually prepare this data and then enter it into SPSS. And this is where your coding comes into play. So when you're thinking about coding the data, you're thinking about preparing this data that makes it first easy for you to enter it into the program itself, so that you could run the analysis. When you have your questions like this, you would notice that we have specific numbers next to each of the response options. So for example, in the first one, we have the first response option is male, the second response option is female, the third is non-binary, and 4, prefer not to say. This makes it easier for you then to prepare the data for entry into SPSS itself. What you would be required to do if you're actually using physical questionnaires that you've passed out is you would look at each of these, and depending on the response option this person selects, that is the number that you're going to note. So questionnaire number 1, question number 1, the respondent chose female. So the code assigned to that particular question becomes 2. So when you go into your SPSS, that is the response option there for that particular question. When you move to your other questions, you do the same thing. So maybe this person was female, but they also fell within the 34 to 41 age bracket. If that is the response option they choose, then the number that is important to you here is the number 3. And I know it doesn't make absolute sense, but when Ms. Aladdin picks up for the other parts in the SPSS itself, it will make more sense, right? So as part of coding, you're going to go through each of your questionnaires, and you should do this systematically, right? A helpful suggestion is to number each of your questionnaires 1, 2, 3, 4, 5 to however many you have. And then for each of these, you go through each question that you have on the variable, and you note which response option the person choose, and you assign a number to it. So for example, in question 5, you would notice I don't have any numbers assigned to it, unlike what I had for the first 2 questions. I would then manually assign numbers. So response option 1 for 0 courses, I could put 1 there. For 1 to 3 courses, put the number 2. For 4 to 6 courses, the number 3, and 7 to 9 courses is the number 4. I manually now put in these numbers, and based on the response option of that respondent, I would select the number then. So maybe they did 4 to 6 courses. So I know for this question, 4 is the response option. 3 is the response option or the code that indicates the 4 to 6 courses. And that is part of you manually coding your data. Now, the nice thing about using online surveys is sometimes this skips that step for you. And when you pull your files, your Excel sheets and that, if you go through the process of putting the numbers in place, it actually could erase that step for you or skip that step for you. But in the event that you haven't done that, or in the event that you're working with actual questionnaires, this is where you putting codes or manually adding codes to your questionnaires would help you as part of preparing that data for entry. Okay. So I'll stop here and I'll hand over now to Ms. Aladdin, who's going to walk you through now actually entering this coded data into your SPSS itself for analysis.
All right, thank you, Ms. Samlal, and good morning again to everyone. So I'm just going to share screen, and the first thing I'm going to share screen would be an empty SPSS file. And then my next screen will be what a complete SPSS data file would look like, or at least a semi-complete SPSS data file. And we're going to use the same example that Ms. Samlal just went through, which actually follows nicely from what Dr. Esnad started with. So as Dr. Esnad said, we have been engaged in the department in trying to understand the whole issue of statistics, anxiety, and performance within the different statistics and research courses. And that would serve as your literature review, and that's where you would get your hypotheses, which would then lead to a questionnaire, as Ms. Amlal explained, in terms of how you design it based on your variables and correctly selecting the level of measurement that makes the most sense for that particular question. And that directly affects how you do your analysis. And that directly affects if you're able to use SPSS or Microsoft Excel or any other program that can do statistical analysis, if you can do it properly. Because unlike a researcher who is doing it by hand, a computer program can more or less run any statistical analysis that you tell it to run. And in that way, you run the risk of doing the wrong analysis or interpreting it incorrectly if you don't do what Ms. Amlal said, a thorough literature review, ground yourself in a theoretical framework, construct your hypotheses, and have an idea of how these variables should be measured and what exactly you're looking for in terms of your hypothesis testing, which is what we will look at later on in today's session. So this is what an empty SPSS file looks like. So when you collect data from hundreds of people, maybe thousands of people as your sample, there's no way that a researcher can accurately conduct the analysis by hand. So in introductory statistics or in any introductory statistics course, you learn how to do those calculations by hand. You learn how to construct a frequency table by hand. You learn how a graph and chart is constructed by a researcher. You learn to calculate central tendency, variability, etc. But in reality, a researcher would rely on a computer program to do that. And that's because the amount of data that you have to try to do those same calculations using a handwritten formula can again run the risk of you making mistakes. And those mistakes are kind of eliminated once you use a statistical program, but only if you know how to properly use it. And if you tie it back to the way you've measured your variables and your descriptive and inferential analysis that you want to get out of your project. So when you open SPSS, and SPSS is available for all students to download via your student portal. So if you would like to practice what we do today, you have the option of downloading the SPSS program and then doing the analysis for yourselves. When you open it, it opens like this. So this is the empty SPSS file. And you'll see at the bottom here, it has two views, variable view and data view. So variable view is what is set up by the researcher, maybe even before you actually do your data collection. So once you have your questionnaire, as Ms. Amlal went through, the first thing you need to do would be to input what those questions are. SPSS doesn't know, as a computer program, it doesn't know what you are looking for. You have to tell it that these are the questions I have collected data on. And that's the first thing that you would do. So as you would have noticed, all of the questions on that questionnaire are numbered, and all of your questions on a questionnaire should be numbered. So the SPSS variable view really relates to the questionnaire itself. And on the left-hand column here, you'll see it's numbered. So these would be the numbers of your questions. And then it has this information that it needs: the name of the variable, the type, the width, decimals, label, values, missing columns, align, measure, and rule. And we're just going to look at the most important of these pieces of information. So the first thing you need to do would be to give each of your questions a name. So for simplicity, we can name them according to the numbers. You can have question 1, question 2, question 3, etc., corresponding to the numbers on your questionnaire. And once you type in the name, you'll see that all of the other pieces of information start to activate. So the first thing you would need to tell SPSS would be, what type of question is this? Is this a numeric question, meaning did you ask people to select responses? Was this a close-ended question? And that would tie into what Ms. Amel said about numbering the responses, because SPSS as a statistical program actually only works with numbers. So once you have close-ended questions where people have been asked to select 1, 2, 3, 4, etc., as whatever response applied to them, then this is what numeric means. The next important piece of information would be the label. So the label is what is going to be displayed when you generate a graph or a chart or a table in SPSS. So the question name could be anything, because only you as the researcher is going to see this. So the name has to make sense to you. The label, on the other hand, has to make sense to your audience. So when you generate a report, you will have to provide a label. For example, this is a pie chart showing the sex of respondents. This is a bar graph showing responses to question 5, and so on. So the label is what SPSS is going to automatically display when it generates a table, a chart, a graph. So for this one, you can put, let's say that question 1 on our questionnaire is the sex of participants. So that when you create the graph or the chart for sex of participants, people who are reading your report, which would be in one of your final stages of the research process, will be able to see, right, they are reporting on the sex of participants. The values is where those numbers that Ms. Amel talked about comes into play. So all of your responses on a questionnaire should also be numbered. And using the first question as the example, the question was to indicate your sex, which is why question 1 is labeled sex of participants. And we had 4 options, and those are basically the values and the labels. So option 1, you put number 1 here, and the label that went along with that first response option was male. And then you click add, and it goes here, meaning SPSS is now storing the variable information for this question. Then you go 2, so 2, number 2 was labeled as female, and you click add to it stores. 3 was non-binary. And then 4 was prefer not to see. Right, then you click add, you make sure all of your responses are here. So this would be the exact same responses on the questionnaire. And this is the responses that people would be choosing from when they do fill out the survey for you. Then you click OK once you're satisfied that all of this is correct. And now this is stored in SPSS. So as Ms. Amel said, when you are entering data into a computer program, you're entering it as numbers. So SPSS is going to know that anybody who you said their response is 1, these people are male. Anybody who you say their response is 3, these people are non-binary. Any people who selected prefer not to see, then you're giving them the code of 4, because SPSS itself can't read the words. It's designed with computer algorithms and so on. So it can't read the words, but it will read the numbers that you've assigned it and do the analysis using those numbers. Connected to that would be this important area here called measure. And these are the levels of measurement. So all of them will come up as unknown because SPSS literally does not know how you have measured this question until you click it and you tell it what level of measurement. Which means that you as a researcher, you as a research student, have to actually know what these levels of measurement are. SPSS is not going to tell you that you've entered the wrong level of measurement. It will assume that the data you are inputting or the information you're inputting is correct. So the scale is what SPSS uses to indicate that this is interval or ratio. So it groups both of them as scale. So if you have an interval question, if you have a ratio question, you will indicate that this is a scale variable. If you have an ordinal question, then you indicate it as ordinal. And if you have a nominal question, you indicate it as nominal. And in this case, this is a nominal question because it's categories that people are choosing which one they belong to or which one they identify with. And you will do that for all of your variables. And that's because your level of measurements directly affects all of the analysis that you could do, as you would know from your SOCI 1005 and your other research courses. A researcher cannot simply do a pie chart if their level of measurement doesn't fit with what a pie chart requires. A researcher cannot do a Pearson correlation, for example, if their data has not been measured at the correct level. And also if you haven't told SPSS what level it is. So if your question is actually nominal, but you indicate that it's ordinal, SPSS is going to run the analysis as if it is an ordinal question. It's not going to pick up that you either clicked on the wrong tab or you entered the wrong piece of information. And that also puts a limit on what type of analysis it will actually be able to perform because it's reading all of this information as if it's correct. Another important thing would be this missing value here, this missing column. And this is if people did not complete questions. So if you go through all of your questionnaires and you see that everybody has answered all of the questions, then you could leave it as no missing values, meaning you have no missing responses. Everyone answered your questions. If you have missing data, so if you have a questionnaire and let's say 5 of the questions were left blank or 2 of the questions were left blank, then you need to tell SPSS what you're going to do with that data. And the most used number are the 3 nines, which has been coded to represent that people left out this question. It's a missing piece of information, and then you click OK. So anytime somebody didn't answer a question, you don't leave it blank in SPSS. Instead, you enter 3 nines, or you could enter variations of 9. But for explanation purposes, we're just leaving it at the 3 nines, which means SPSS will know not to put in any information for that person. This person did not enter a response for the question. They're missing data, and therefore they should be left out of the analysis for whatever question you're doing. The next view, so you go through this process for every single question on your questionnaire. The next view is the data view. And once you put the variable name in this first column, it activates the data view. And these will then become the responses that people gave you for these questions. So if question 1, the person is a male, then you type in 1 as the response. If respondent 2 was non-binary, then you type in 3 as their response. And then you continue for all of your other questions. So on this sign, these numbers refer to the questionnaire itself. As Ms. Samuel said, it's best for you to number your questionnaires. So respondent 1, respondent 2, respondent 3, and so on. And it can take how many ever respondents, meaning however many people you had in your sample. And you go through and you do that for each question and each questionnaire. As Ms. Samuel indicated, this part of the process is shortened if you do it as an online or a web-based survey. For example, Google Forms, like what we have asked you all to do. So that will allow you to be able to actually download the data as either an Excel file that can be copied and pasted directly into SPSS, or some programs actually allow you to download as an SPSS file, and in which case you have the data already, and all you need to do would be to set up the variable view. So it knows what questions it is that you're doing the analysis for. So on your screen now would be a complete SPSS file. So I'm just waiting for it to become fully visible.
While we're waiting, I just wanted to mention, if anybody has any questions, please feel free to place them in the chat. And for anybody else who came in late, if you didn't already fill out the icebreaker survey, feel free to do so as soon as you can. Thanks. So while Ms. Aladdin reloads her screen there, I also wanted to mention, in terms of the names of the questions, there are some rules regarding the symbols you use. So you would probably notice, some of you, when you enter the name of the question or the label for the question, the name of the question, sometimes you would notice you cannot use like a full stop at the beginning of the name. There can't be any spaces in the names, those sorts of things. So there are little nuances in between with respect to naming the questions. So remember, those types of things may cause you errors if you actually enter the data yourselves. And also, just to add to what Ms. Aladdin said earlier, in terms of software, if you were to do a SurveyMonkey analysis, say you send out a link via SurveyMonkey, you can actually retrieve the Excel document, depending on, I think if it's a paid version or the free version, you should be able to retrieve the Excel document where you could actually import that into SPSS as well. And you would have all of your responses in there. Sometimes, same thing as they mentioned before, both Ms. Samlal and Ms. Aladdin mentioned before, that you would actually have to code it and actually have the meanings of the actual responses there. So let us see if it is we can. Yes, and Ms. Brito mentioned in the chat, to add to that, the SPSS allows the name underscores any name as well. So you would notice the name of the variable, it's something that you could put, it's any sort of name. It doesn't have to be something extremely fancy. It could be something very short. And then you could actually have a proper label to go with that. So we're just having a slight technical difficulty in the meantime. In the meantime, I just wanted to ask if anyone has any specific topics that they usually, or any specific questions, just in general, before we continue, in terms of your experience with the courses so far that you have been doing in statistics, any sort of difficulties that you usually have. I actually asked my classes the other day about the types of topics or the types of difficulties you encounter when doing statistics in your courses. If you could place those things in the chat in the meantime, so we could actually collate that and have a short discussion in the end regarding those things, that would be very useful. Miss. Okay, so we just have a slight technical difficulty with Miss Aladdin's screen. So just give us 1 second to work that out, and we'll be with you shortly.
Hi, so while we wait, I'd just like to address the question in the chat, unless Dr. Addison, you want to proceed, and we can address in the segment, the Q&A segment.
Yes, yes, and feel free to continue. You all can continue putting your questions in the chat. If everybody could see the screen now, Miss Aladdin and Miss Samlal can continue. You could just direct me as to which parts of the screen you want me to show.
Okay, so the first thing would be the frequency tables. So in SPSS, you're able to do all of your analysis using that Analyze tab. And so Dr. Addison is just going to show how to generate a frequency table for the first question, which would be sex.
Now, remember, we have a lot of different variables, where we have a lot of different tabs here. So Miss Aladdin will just direct me as to which ones she wants you all to see at this time. But feel free, as students, you all know there are other statistics that you may want to add for certain variables, right? So Miss Aladdin, you could continue. You could direct me as to which one so we can tell the students.
All right. So in addition to doing your frequency tables, you could also click on the statistics tab that Dr. Addison just clicked on. And that will allow you to do like your central tendency, variability, and positions. So since this question is a nominal question, the central tendency and the dispersion wouldn't really apply. So we could cancel this box and then we can show the chart. So you could choose if you want to display it on a bar graph, a pie chart, or a histogram. And since this is a nominal question, we could go with the pie chart. And then you click continue. So you could decide if you want to display it in frequencies, meaning the actual count, or as percentages. So we could leave it as frequencies. And then if you click continue, SPSS will automatically generate the table, or click OK, and then it automatically generates the frequency tables and the graphs for you.
And just to add to that, well, you could also indicate in terms of your first table, you could see if there's any missing data. And of course, Miss Aladdin already addressed dealing with missing data as well, right? So this is the actual way the frequencies look, and we actually have the percentages as well.
Dr. Addison, it's still on the SPSS view for us.
Oh, sorry. I always have this issue. Stop sharing. Let me share this again. Right. There you go. I'm not sure if you all are seeing it.
Yeah. So
Right.
we're seeing the pie chart.
There's some black screen around it. I'm not too sure why that's happening. Okay, great. So you all are seeing the, let me just minimize and bring it back up. Are you all seeing it now?
Yep.
You all good? Okay, great.
Yes, yes.
Yeah. Awesome. Okay, so Ms. Aladdin, you could continue.
All right, so what you're seeing on your screen is the pie chart. So SPSS does all of the graphs and charts for you, but you need to connect it to what is the appropriate chart based on your level of measurement. So as you should know from your statistics courses, nominal and ordinal data could be shown on pie charts or bar graphs, and you choose whichever one you want to actually generate for your report. And then the scale or the interval and ratio ones, you could use the histogram, or you could use line graphs, frequency polygons, etc. So this would be your pie chart, which can then be copied and pasted into your report, but has to be formatted based on whatever referencing style you are using. If it's the APA style or the Chicago Manual of Style or another format. So you don't just copy and paste your pie charts or your graphs and your frequency tables straight into SPSS and use it in that form. In some cases, you might need to adjust the formatting a bit so that it actually fits with how your required formatting style requires. Did the frequency table come out?
For the text, yes.
All right, so on top, the frequency table there would be for the number of participants. So in this case, we have 4 people who said they are male and 12 people who said they are female. So this is just a small data set of 16 students who did the survey in class. And you'll be able to do this for all of your questions. And the frequency table basically gives you a count as to how many people chose a particular response option. And you can do this for all of your questions. So you decide if you want a frequency table to be generated for all of your questions, or if you want only a graph or a chart generated for all of your questions. So we can do, yeah, we could do that one, how you rate your overall experience. And this one, we could select the chart or bar chart. Yeah, we could select percentages for this one so they can see the difference. And then you click continue and then okay. And SPSS automatically generates a frequency table unless you indicate for it not to. So in this case, the question would be, how would you rate your overall experience in doing statistics and or quantitative research courses at the UWI? So that would have been the question that you asked the respondents. And the first thing that you're seeing is the frequency table. So 6 people responded neutral, 7 people responded good, 3 people responded very good. And it also calculates the percentage for you. So unlike in SOSI 1005, where Ms. Amlal and I would have taught you how to actually work out the percentage, in this case, SPSS does it for you. But you need to know how to interpret it. So you need to know that 18.8% out of the people who responded to this question out of my total sample size indicated that their experience was very good. And then this same information is now being displayed on the bar graph in terms of percentages. So you'll be able to see that the majority of people, because the bar is the highest for the good response, the majority of respondents said that their overall experience was good.
I also wanted to jump in to mention that a lot of you would probably see what we call syntax, which is every time it generates some graph or some sort of procedure, you would see a lot of commands based on whatever algorithm the software provided in the back end. Now, this is very useful and it's actually very reproducible, especially if you had a lot of procedures that you have done. You could actually use this, just to mention this very quickly, you could actually reproduce that code if you go into open syntax and you could put in, new syntax, you could actually put in that code there and it would generate the same information for you. And for persons who have a more of a programming background, this would probably be very useful because sometimes instead of pointing and click, you could actually input that there, change the variables, and then just run the code and we'll do it for whatever. If you have a very, very large data set and you don't want to keep doing point and click, you could actually put all the information into the syntax window and do the very same thing. So you could continue, Ms. Aladdin.
Right, and then
as we go along, don't forget to put any questions in the chat. Yes, go ahead.
So the last one we'll show is one for a scale question. So again, you go to descriptive statistics. So the good thing with SPSS is that the Analyze tab has all of the analysis that you would want to do. So under descriptive statistics, it has all of these different options. And again, you choose exactly what you want to do. So we can do the frequency again, and we'll choose the age group. Yeah, the age group of the students. So that would be question 2. Right, so then again, so if you click on the statistics, so this one we can show how the statistics could be done. So we can select like the mean for under central tendency, and if you want the standard deviation under dispersion, and you can choose other things as well, depending on what you as a researcher wants to report. And then, so under central tendency, it has all of the measures. Under dispersion, which is what it calls variability, it has all of these measures. Then it has ideas for your distribution if you want to see if it's normal or if it's skewed. And then it has the percentile values if you want to know the exact location of a particular score. But we can leave it just as mean and standard deviation for now, and then you click continue. And then the chart, this one we can do a histogram. You can do histogram, and we can click for it to show you if your data is normally distributed. And again, you click continue and OK.
Just wanted to mention that this is SPSS version 27 that we're using. So older versions may not have this create APA style tables here, just for the reference of students who are using an older version.
Right, so again, it has the frequency table. And in that frequency table, in the statistics table above, we have the mean and the standard deviation. So again, you no longer need to work out things by hand. You no longer need to actually refer to a formula sheet or a textbook to work it out, because SPSS will do it for you. But you need to ensure that you understand what it means. So you need to know that the mean means this is the average age of your respondents, your standard deviation. This is how far people are deviating away from this mean, because that's the kind of information you need to put into your report. You can't just give your audience just a table without any explanation. And the same with the age group table. And then below it has the histogram. And SPSS positions the normal curve onto the histogram if you request it to. So you're able to see if your data forms or follows a normal distribution. And in this case, we could see that it doesn't look like a normal distribution because the majority of respondents are in that 18 to 25 age group. And there are very few respondents in the other age groups, which we could see from the frequency table. So both the frequency table and whatever chart or graph you create will show the same information, but you as a researcher have to be able to interpret that information and then speak to it in your report. So I think Ms. Samuel just had a few points on when you're actually reporting these.
Right. So when you're reporting these, you have to be aware of whatever formatting style is required of you for whatever document you're producing. If you're doing an actual full study, if it's a research paper, whatever you're using these for, you have to be aware of your formatting style. So I know psych students, they would more use the APA style. Sociology students are more required to use the Chicago Manual of Style. So you can't just take the tables and the charts straight out of SPSS, well, depending on the version that you're using, because as Dr. Addison just pointed out, one of the newer versions would have that option available to use APA style. But if you're using the older versions, that may not be readily available to you. So you have to be aware of the style that you're using. When you're positioning these into your documents as well, your final report, you also have to be careful to label these well. And again, according to your formatting style, but it's not just a case of you copying and pasting or just putting a table or a chart and saying that this is this chart. There should be a numbering system for figures, charts, tables, and that is how you make reference to these within the writing itself. Finally, when you're putting these in your final report, you don't just slap in a diagram. You don't just put a pie chart and a histogram and expect your readers to just know what these are about. In addition to labeling, there should be some kind of description making reference to these diagrams. So based on figure, whatever it is, based on table, whatever it is, and you describe what you're seeing within these diagrams itself. Is it the distribution you're interested in, the frequencies you're interested in? There must be some reference to connect all of these back into the report that you are producing as part of your research itself.
Also wanted to mention that you could double click on the chat editor and you could actually change around colors and different things inside here. And I also wanted to point out as well that we did not assign the numbers to the age groups in the variable view. I don't know if anybody would have noticed. So that is something that you would have to do. So for instance, remember, this is not an exact science when you're doing this. Sometimes you would actually realize in your actual results that there may be things that you forgot to do, or there are things that you need to do. So when it has to be meaningful, if I look at this chart and you realize I have 1, 2, 3, 4, and persons will not understand what that means, then you'd realize, okay, let me go back into my variable view and actually adjust the values so that when it comes up in the output, as Mr. Ladin spoke about earlier, that you would see the meaningful values of the different categories that the age groups are in.
Right, and that's important to note. So your analysis, you're doing this analysis for 2 reasons. You as a researcher wants to figure out the answers to your research questions and achieve your objectives and test your hypotheses. But this output is also going to be for your audience, whether that's going to be a class presentation, if it's going to be in a journal article, if it's going to be in a book, if it's going to be presenting at the United Nations or the World Bank or for a ministry. So you need to ensure that your charts and your tables are not just understandable to you as a researcher, but that they're going to be able to be understood by whoever your audience is, a written audience or a visual spoken audience. And the last thing we'll show is how to do a cross-tabulation or contingency table. And for that, you go specifically to crosstab. And a crosstab shows 2 variables at the same time, which means you need to know what these 2 variables are that you're interested in. So let's say we wanted to see if sex is associated with how excited you are to be participating in the session. So sex would go into the column tab, and then how excited goes into the rows. And then we could display this on a bar chart as well. So you could click at the bottom, display clustered bar graph, bar chart. So in placing the variables into the columns and the rows, your independent variable is what goes into your columns. And then your dependent variable, the one you're assuming to be a dependent variable, goes into your rows. So again, the placement is important in SPSS itself, because it's not going to know exactly what variable is which. You as a researcher have to know conceptually how you've understood these variables so that when the output comes out, you're able to interpret it. And now we can just click. Right, so our statistics, if you click statistics, you can actually select if you wanted to do a chi-square at the same time. And if you want to have any of those other pieces of information, whether it's a nominal or ordinal data. So the second segment is going to go more into the inferential statistics. So we're not going to touch on this as yet. For now, we're just looking at the crosstab itself. So you can click OK, and then it will display just the most basic cross tabulation. And so the second table, sorry, so the one that you're seeing, how excited are you, and a cross tabulation. So in this case, it has sex at the top, which would have been male and female. So nobody selected the other 2 response options. So that's why only male and female are being displayed here. And then on the side, it has the responses for the how excited they are to be participating in the session. So we have not at all excited, 3, 4, and then very excited. So no one would have selected option 2 for that question. And then the interpretation here becomes important. So 1 male said that they're not at all excited. And then 2 males said 4, so whatever 4 you would have interpreted 4 to be maybe excited. And then the females, 6 females selected option 3, which would have probably just been neutral, like neither excited or not excited. So again, SPSS only gives you tables and charts. It doesn't tell you what these tables and charts means. That's where the the statistical knowledge comes in. So once you have a grounding as to not just how to calculate something or how to draw something, but how to actually interpret what is, in this case, my cross tabulation supposed to tell me, or what is this bar chart supposed to tell me, that's when you can then make this into something meaningful. And the bar chart is showing both males and females and how they selected each response option. And this is where, as Dr. Addison mentioned, putting in the actual values that corresponds to the numbers becomes more useful to your respondents and to your audience. So you as a researcher might know, I only need to give words for the first option, not at all excited, and the last option is very excited. And that might be sufficient even for your questionnaire. But for your audience, you would need to tell them that what 2, 3, and 4 meant, so that when it appears on the bar chart, they actually know what it means. So we can do one more of these where we had all of the responses stated, so they'll be able to see it. So we can again do sex and how they would rate their overall experience doing research, which is question 6. Right, that one. And then again, you can just click OK and you'll see all of the responses. So in this case, we have neutral, good, very good. So nobody selected the response of bad or very bad. So it only displays the responses that you actually collected. So 3 males and 3 females had a neutral experience doing statistics and research courses. 2 females had a very good experience. 1 male had a very good experience. And that's the same information that's now displayed on the bar chart. So if we look at neutral, we have the same number of males and females. So males have been represented by the blue, females represented by the green color. The females are the only ones who selected good. And then very good is split between 1 male, which is represented in the blue bar, and 2 females represented in the green bar. So in this case, it's showing how these 2 groups responded to the same question. And that could be useful if you want to actually make some kind of comparison as to how people responded, just based on their bare responses alone. If you want to go a bit deeper, then the inferential statistics will come in there. And as Dr. Addison said, if you click to activate it, you can actually change the colors. If you're not satisfied with blue and green, if you want to change the colors to something else, you could change the colors, you could change the style of the chart if you wish to. And again, keeping in mind what would be required for your specific referencing format.
I also wanted to mention that at this point, when you do your descriptive statistics, that you could actually, as Ms. Aladdin mentioned, you make these observations, and that could actually shape certain things that you could put into your inferential, or will actually shape what your hypotheses can be as well. As you could see, a number of people said they had a good experience there, much more than the other, the neutral and very good. And then there was nobody else in terms of males who did not, there were no males in terms of the good experiences and those things. So those little nuances in your data, especially in the descriptive or exploratory portion, it's really good for you to make those observations. So that is actually a bridge now for you to determine, is there something else I can test here within the inferential statistics? Right. So we have come to the end of our first 2 segments. So what we will do, we'll have a short break now until 11:30, a 15-minute break. And please feel free to continue to place your questions in the chat. So when we return at 11:30, we'll do segments 3 and 4, and we will have a short discussion based on all your questions. So let's thank our speakers, Ms. Farina Aladdin and Ms. Keisha Samnal, for segments 1 and 2, very, very informative. And I'm sure you picked up some things that you probably didn't know before with respect to actually inputting the data and analyzing the descriptives and frequencies.
Hi, Dr. Addison. I'm just checking my audio.
Yes, hearing you loud and clear.
All
Yeah,
right, so
I'm
it's
hearing you.
fine.
Okay, so now it's 11:30. I hope everybody got to stretch and get a little snack and get some fresh air so we could resume and be on time. So at this point in time, I will invite Ms. Aladdin to show you all some of the results from the icebreaker survey, so you could capture some of those visualizations based on what we just spoke about in the first two segments.
All right, thank you, Dr. Addison. So the survey that you all did is our icebreaker survey, and the data that we were using for the descriptive section is just a shortened version of it. So some students in our lectures had completed it last week, and that's kind of like how a pilot study works in research. You do a smaller version to check that your questionnaire is easily understandable. You check to see how the data is looking before you do your full-fledged data collection. And in our case, this would have been done using that Google form, which is one of the most used ways of doing surveys now, especially considering that face-to-face interaction is either not allowed or is difficult to do. So this would have been a Google form. So you would have the actual form, and this is what you would send to respondents, just like we sent to you. The good thing with these web-based surveys is that it allows you to be able to collect the data at a much faster rate and easier to get it into SPSS, or if you're using any other program. So if we click on responses here, it gives you an idea of how each person responded. So Google actually does the descriptive statistics for you without you telling it what to do. In terms of the charts and graphs, it doesn't work out the mean, median, mode, central variability, or any of that. It does pie charts and bar graphs for all of your questions, which means it also doesn't know the level of measurement. So it doesn't know if the chart or graph it's doing is correct, which is why you shouldn't use this as your go-to for data analysis. And because it's not designed for statistical analysis, but just to give a general idea of how respondents responded. And then it also allows you to be able to download it in an Excel format. And this again will shortcut the need for you to directly input your responses by hand. So once you download this, it opens as an Excel format, which can then be either copy and pasted into your SPSS, into your data view, or if you want to import it directly. So it depends on how it's downloaded and what you want to do with the data itself. And once you have that there, then you're able to do your analysis, like what we showed you, the descriptive analysis, and then your inferential analysis. But Google Forms or other softwares are not necessarily designed for the inferential part, especially ones which aren't really designed for data collection in terms of research, but just in a broad sense. So these are good as an introductory descriptive analysis, but SPSS or another program should still be used to get beyond just basic graphs and charts, and definitely to do your inferential statistics, which is what Dr. Addison and Ms. Brito are going to go through with you all now. So I'm going to stop sharing my screen, and then they will continue for the other two segments, looking at the inferential analysis and then how you actually report your results to a particular audience.
Good morning again, everyone. Thank you very much, Ms. Aladdin and Ms. Samlal, for taking us through exploratory and descriptive statistics. And we now dive into the world of inferential statistics. So I will be joined as well by Dr. Addison for this segment. So descriptive statistics, they allow us to describe data, whereas inferential statistics allow us to make predictions or conclusions, those inferences from our data. So this is where we can dive into hypothesis testing and so on. But before I go into that further, we will be switching gears and looking at a case study. The topic is the impact of COVID-19 on the well-being of adolescents in Trinidad and Tobago. We have 150 adolescents from ages 13 to 18 across various communities in Trinidad and Tobago, and it was a cross-sectional study. So the data was collected online via a structured questionnaire. Some information on our variables. So we have age that was measured as raw scores. Exposure to COVID-19 asked the question, were you a primary contact of someone who was diagnosed with COVID-19 in the last 6 months? And the response options were yes or no. Socioeconomic status, or should I say perceived SES, was categorized as low, middle, and high SES. We also had our Likert scale questions. So inter-household contact was measured with 2 subscales, the face-to-face and the virtual contact subscales. So it looked at contact during the pandemic. Face-to-face asked respondents how often they met up with certain categories of individuals. For example, children, other family members, friends, etc. in the past 3 months. Whereas the virtual contact subscale asked the same questions related to meeting up via phone and social media. So the items were on 6-point Likert scales, ranging from least frequent to most frequent. So higher numbers on each subscale would indicate greater contact. And then we have our mental and emotional well-being variable, which basically captured depression, anxiety, and stress. And this was collated into a composite variable. So the DASS 21 consisted of 21 items on a 4-point Likert scale, ranging from strongly agree to strongly disagree, and higher numbers on both subscales suggested greater well-being. So we had a number of research questions, and just to give you all a sense, so we have the research questions, the objectives, and the hypotheses, and we will be tackling these individually as we go along. So, for example, is exposure to COVID-19 associated with socioeconomic status among adolescents? And we will have a closer look at those hypotheses later on. The other question, what relations exist among age, exposure to COVID-19, inter-household contact, and mental and emotional well-being among adolescents? Then we want to look to determine if age, exposure, and inter-household contact would predict mental and emotional well-being. Fourthly, is there a difference in face-to-face inter-household contact based on whether adolescents were a primary contact of someone diagnosed with COVID-19 or not? And our 5th research question, are there socioeconomic differences in adolescents' mental and emotional well-being? So, as I mentioned, we will be talking about inferential statistics, and one main use of inferential statistics is hypothesis testing. So hypothesis testing allows us to investigate our ideas about the world using statistics. And so we use it to test our hypotheses that arise from our theories. So we can draw conclusions about an entire population based on a representative sample. So these are some of the things that we'll be covering in this segment: chi-square test of association, correlation, regression, t-test. ANOVA will be generally looking at assumptions as well as some non-parametric tests. So when you are engaging in hypothesis testing, you have to have your null hypothesis and your alternative hypothesis. The null hypothesis is the one that states there will be no difference. In other words, we expect the effect to be absent. For example, if we look at an example of a clinical trial, let's say we're trying to treat anxiety and we're testing a new drug, the researcher might be interested in whether a new drug is better on average than the current drug. And so the null hypothesis would be there's no significant difference in anxiety between those 2 drugs. So they have no effect, the new drug, or no difference between the 2. And the alternative hypothesis is that there would be a significant difference in anxiety between those 2 drugs. As a general rule of thumb, although this may vary depending on the discipline that you're in, we reject the null hypothesis if the p-value is less than or equal to 0.05, and then we make our relevant conclusions based on what we find. Beginning with chi-square test of associations, So a chi-square test is a test of independence, or you're looking at whether your variables are associated or related. So you're looking to determine if there's an association between categorical variables. This is actually a non-parametric test. All right, so you don't assume what we would normally assume for a parametric test with the case of chi-square. For example, you don't assume that your data is normally distributed. All right, an example of a question that you can phrase for chi-square, you're looking at, are the variables independent or related or associated? I would like to mention at this point that chi-square cannot provide inferences about causation. So you would want to avoid making causal claims when you are interpreting chi-square results. So looking at the main assumptions that we have, you can have two categorical variables, and each variable can have two or more categories or groups. Another assumption would be independence of observations. In other words, the categorical variable should not be paired in any way. So if you have like a pre-test or post-test observations, this would not be suitable for chi-square. So you wouldn't use chi-square for repeated measures design. You would want a relatively large sample size, and the expected frequencies should be at least 5 for the majority of the cells. So if you think back to the crosstabs that Ms. Aladdin and Ms. Samuel did, within those cells, you want at least 5 counts within the contingency table or the cross tabulation table. Looking at Pearson's correlation is a parametric test, and it is used to measure the strength and direction of linear relationships between two continuous variables. So we might ask, is there statistical evidence that a linear relationship exists between these two variables? All right, so you can really check the correlation between two variables at a time. So you're checking to see if there's a linear relationship between these two variables. And with a linear relationship, we can look at direction. For example, whether it's a positive or a negative relation. So if the two variables are going in the same direction, essentially, for instance, if both variables are increasing or both variables are decreasing, that's a positive relation. And then a negative relation would be when the variables go in opposite directions. For example, as one increases, the other decreases. And then you can also speak about the strength or magnitude of a relation. So how close the relation is to being a perfectly straight line. Those correlation values can range from -1 to +1. So the closer your correlation value or your correlation coefficient is to 1, the stronger the correlation, whereas the closer it is to 0, the weaker the relation. Main assumptions would include normally distributed data and linearity, for instance. Moving on to multiple linear regression. So this is a step above correlation now. We are looking at prediction. Regression involves the prediction of the value of one variable from another. It again uses a linear model to describe the relation between two or more variables. So the question we ask, is there evidence that the predictor variables linearly predict the outcome or the criterion? So you might see these terms being used interchangeably. The predictor is like the IV, and the outcome or the criterion is like the DV, which is a dependent variable. Ideally, you would want your predictor and outcome variables to be continuous, meaning interval or ratio. Simple regression would have one predictor and one outcome, whereas multiple regression would have several predictors, so more than one predictor, but still one outcome. And the main assumptions would include things like normality, linearity, and non-multicollinearity. At this point, I'd like to ask Dr. Addison to come in and take us through group comparisons.
Thank you very much, Ms. Brito. So to continue with the tests, we're going to mention t-tests now. Now, in specific, there are a few different t-tests you might be aware of in terms of independent sample t-tests, and there are also pair t-tests. we're just going to concentrate for this particular study that we're going to do in the demo on independent samples t-tests. And that means that we're going to compare means between two independent groups on the same dependent variable. So for instance, a research question could be, in general, are there significant mean differences between the independent variable in terms of the scores of that variable in two groups? For instance, if you have males and females, and you have the anxiety scores based on the drug that we mentioned initially in terms of taking a particular drug, we could compare the anxiety scores based on taking that drug for males, and then we could compare the mean differences for females and see if there's any significant difference in those means. So the main assumption is that the dependent variable has continuous or scale values, and the independent variable consists of two categorical independent groups. So remember, we want to make sure that you all understand the fact that the variables have to be specific types of variables to use specific tests. The independence of observations is also key, as Ms. Brito mentioned before. In this specific test, it's actually two distinct groups rather than a pre-test and a post-test, which would come into a paired t-test. So that's a variation of this t-test. The dependent variable must be normally distributed within each of the particular groups. And we say that loosely, approximately normally distributed, because a lot of the times people tend to wonder, what does that mean in context of how to do this in terms of SPSS? I would say, as a statistician, in my experience, if you have a very large sample size for each of the groups, you could assume normality. And if not, you can use the same histograms that Ms. Aladdin mentioned earlier to look at the skew of the data and determine if it's approximately normal. It doesn't have to be perfect. And of course, homogeneity of variances, which in this particular test is a very important assumption. We call it the Levene's test, so the Levene's F test for equality of variances. That word homogeneity and homoscedasticity and all these very fancy words are actually just to be able to tell you the scatter of the data. Because remember, in terms of this kind of data, if you plot a graph, you would actually see the cascading scatter of the points that you've got. If it is that there's a large variation, it's going to cause a lot of bias. So we need to make sure there is some sort of equality within the variances so we could actually test those assumptions and then continue using the test and make a proper conclusion. Next slide. So continuing the trend, now I would say analysis of variance is actually an extension of a t-test, because it's actually essentially doing the same thing, and there are various types. Now, the ANOVA method, we will talk about a one-way ANOVA, and I will mention two-way ANOVA if there is time. But what a one-way ANOVA does is that it compares the means between, it's actually supposed to be, three or more, right? So three or more independent groups of an independent variable with one dependent variable. Why I say three or more is because the t-test is used for two groups. And the ANOVA actually is an extension of the t-test, which is actually used for more than three groups then. So if you want to look at significant mean differences among the independent variable in terms of three groups, let's just say, to give you an example in context, we could look at the differences in probably GPA scores for different groups, year ones, year twos, and year threes. If you were to use t-test, you would have to use t-test for each of those pairs. That would take you too much time. So you could actually use an ANOVA, which will actually incorporate all those three groups into one test. So in terms of the assumptions, we have similar assumptions from the majority of these tests: independence of the observations, normality in terms of the dependent variable. And why we keep stressing normality is because you all would know from your experience, these are called parametric tests. So they are based on the distributions of the data. If the data is actually very skewed or not normally distributed, then we would have other tests we would mention at the end, which are non-parametric parallel versions of these tests. And of course, I had mentioned with the homogeneity of variances, that is actually a Levene's test, which in SPSS you would actually see incorporated within the t-test and the analysis of variance test, which would actually give you an idea of if that assumption wasn't met. And I will also mention to you, I'm just simplifying it to one-way ANOVA, but two-way ANOVA is also possible, and you could actually add two independent variables as fixed factors within the SPSS and actually be able to generate a more compound or more complex analysis. Next slide. So in terms of post hoc tests, now what a post hoc test is, if you've heard the term, and for those of you who have not, It's basically a test that comes, it's Latin, it comes after a main test was performed. Now you would notice in your t-test, you may be able to tell someone that there was a significant difference, and in particularly a ANOVA test, you can tell there was a significant difference among the 3 or more groups that you were testing. But how would we know where those differences lie? So in that particular case, we want what we call a post hoc test, a test which comes after that hypothesis test. And in this particular case, we can talk about 2 different ones. I know some of you will be familiar with what we call multiple comparisons tests in terms of Bonferroni. And there's also the Tukey HSD, or honestly significant difference procedure. So there are many of them. I will mention both the Bonferroni and the Tukey. And there's also least square differences, LSD, and a lot of other tests that come into play. So all of them just use a computation to be able to give you an idea of which groups actually had significant differences if your ANOVA test told you that there was a significant difference among the groups. So it's just a test, a post-test after that. Next slide. So basically, just to summarize and to give you a key idea here, because remember, we won't be able to go through each one specifically, but just to have a visual, the actual idea of comparing means falls under either if you're thinking about between groups or within groups. In terms of the independent t-test, as I mentioned, that's between groups, and a one-way ANOVA for 3 or more groups between the different groups. If you want to look at measurements within the subjects, which is actually more of a dependent type of nature, where you have like pre-test and post-test, you could look at a pair t-test for 2 groups, or for 3 or more groups, you could look at the repeated measures ANOVA, or sometimes they call it the factorial ANOVAs. And then we also have something called ANCOVA, which is analysis of covariance, which introduces some confounding factor. So even if we don't get time to go through each one, what you need to remember is that all of these tests have a basis and assumptions, and they branch out specifically based on your needs as a researcher. So if you find specific factors that you think would be in addition to something that you had as a concrete experiment or as a concrete basis for your research, for instance, if you wanted to do an ANOVA and then you saw some other outside factor, which we call a confounding factor or covariate, you could decide to do an ANCOVA then after your ANOVA and see if that affects your original results. So remember, just to make sure that you don't get overwhelmed with all the different tests, it's actually a very sequential manner that you can do this in. It's not to just jump and do the fanciest sounding test. It's to actually start from small, walk before you run, and then figure out now how you build up from there to be able to use specific tests. Next slide. So just to give you a summary, because as I said, there are parallel versions of these parametric tests. So we basically spoke about associations between the variables with respect to the chi-squared and of course the correlations. The chi-squared was actually the non-parametric version. Now the Pearson correlation is for the interval variables, but you also have a Spearman rank correlation coefficient, which you can use for ordinal variables in terms of correlations. Then we had the differences in terms of the 2 independent groups, the t-test, the independent sample t-test, that's the parametric test. But the non-parametric version, there's also called a Man-Whitney U test. And there are other tests in SPSS you can explore in terms of the health options that you would be able to use in place of that if you violate any of the assumptions like normality and things like that. Differences among groups, the one-way ANOVA. We know, as we mentioned before, the criteria for one-way ANOVA. If any violations, just as with the t-test, you could use a Kruskal-Wallis H test, and that is also available in SPSS for you. So it's just, as I said, everything has a parallel version of a test if any assumptions are violated. So you could feel comforted by that fact. And in terms of prediction, as Ms. Brito mentioned, with the linear regression, there's the parametric test of linear regression. And if it violates any assumptions, I'll also caution about the difference between the logistic regression and the linear regression in terms of non-parametric. The logistic regression has a little more of an extension of what it means. So for instance, if you wanted to predict risk or probabilities, like for instance, I will tell you in my job, I actually use logistic regression as a statistician to be able to build a student retention model based on predicting if a student will drop out or be retained in the next semester. And that model actually, it goes more than the linear regression in that sense. So it actually gives you an idea of, could we say based on these predictor variables, if the student would stay in the system or not. So can I predict that probability and have that as a guide? So that actually creates a lot of actionable results. So I would like to make you all excited about the fact that these tests actually carry you to a part of statistics where you actually feel like you can be guided by something meaningful to be able to produce, especially in terms of research for all of you who will be doing research projects and research papers. Next slide. And in terms of the assumptions, so this is just an overall snapshot. You don't have to get overwhelmed by this. It's basically just giving you an idea of specific tests and where these assumptions lie for different tests, because for specific tests, you would need to, you notice all of the tests, the R, T, and the F test, which is ANOVA, you would have the assumption of normality. Same with the interval or ratio data, the homoscedasticity, which is the homogeneity of variances, assumptions met. In particular, the R and the R squared, which are also related to regression because of the correlations there. You would need linearity, multicollinearity, independence, and all of these things. So that's just basically telling you where assumptions are required. But as a statistician, I will tell you in general, just know the normality assumption is very important. And of course, in terms of, for instance, the t-test and the ANOVA test, that homogeneity of variances assumption is also very important. So you could be guided by those for the most part. Next slide. So now we move on to the next part of the segment. Before we actually show you all the results and interpretation, Ms. Brito and I will take turns in showing you in SPSS how to compute some of these hypothesis tests based on the case study she mentioned. So Ms. Brito, I'll throw it back to you.
Thank you, Dr. Addison. All right, so to put everything into a practical sense, we're going to use the case study data set to actually run the analyses that we would have mentioned. So to orient you briefly to the data set, I'm in the variable view. And as Ms. Aladdin and Ms. Samlal would have mentioned, this is where you create your variables before you actually enter participants' data. All right, and so we have age and socioeconomic status, COVID-19 exposure, and then we have our contact Likert scale questions for inter-household contact. So these would be the face-to-face questions that has been summed, and then the virtual questions that has been summed in row 15. And then after that, we have the questions pertaining to the mental and emotional well-being measures. So we have them as per subscale. So the depression questions, and then we have the anxiety questions and the stress questions, which have been totaled for the DASS 21, which we will be using in our analyses. So the very first one that we wanted to look at was the chi-square. So Ms. Aladdin and Ms. Samlal would have mentioned crosstabs already, so I will focus on the inferential aspect. So we go into analyze, descriptors, and back into crosstabs. And you will see that we can put the IV in the columns and the DV, or what is suspected as the DV, in the rows. We can also go into statistics in the top corner here, this tab, and you can tick off certain things. It depends on what you really want to look at, but let's, at a basic level, let's tick off chi-square and Fine-Kramer's fee. Then we click continue. We can also go into cells, and again, there are a number of things you can do. You can tick off z-tests and so on, but I'll just keep it simple. We'll look at the counts and we'll look at the percentages here that have been ticked off. So we click continue, and we click OK. Can you let me know if you're seeing the output window?
You'd have to stop sharing and reshare.
Okay, so what I'll do is I'll show it at the end, right? Because I feel like switching back and forth might be a bit tricky.
once you're in the output window, you could stay in there and you could do the analyses without showing the data view.
Right. Okay. Okay. No problem. Let me do that then. Right. So, and we will talk more about actually interpreting these in the upcoming segment, but just to kind of give you a sense of how we can read the tables, this is the contingency table with the frequency counts in there. So you'll see that 15 persons in the low SES group would have said no, they would not have primary contact. 31 in the middle SES group said no, and 14 in the high SES group said no. And then coming down to the yes, those who said yes, they were a primary contact of someone who was diagnosed with COVID. 35 in the low SES group said yes, 39 in the middle SES said yes, and 16 in the high SES said yes. Let's come down to, and you're seeing the clustered bar charts that they would have mentioned for the icebreaker data. This is the bar chart here for this data. For this particular analysis, I want to focus on the Pearson chi-square test statistic. We see the value is 3.175. The degrees of freedom is 2, and the p-value is 0.204. So that is greater than 0.05, which means we have non-significant results here. All right, and you will see the write-up for that in the next segment. So this is where we'll pull our values from. And you're seeing also phi and Kramer's V. So these deal with, they look at the measure of the size of the relation between the two variables, all right? So they look at the strength and direction of the relation, but in this case, we wouldn't need to really delve into that as we don't have an association. We don't have a significant association between our two variables. So that would take care of the chi-square, and I would like to move on to the correlation analysis as well. So I'm going back into analyze, then correlate and bivariate. So analyze, correlate, and bivariate. And what I can do is I can plug in my variables there to generate a correlation matrix. So I'm just going to put the pointer in this area where the variables are listed. I'll right click and display variable name so that I can see it better. And I'll plug in all of my variables there. So we had age, COVID-19 exposure, face-to-face contact, virtual contact, and the DASS, which is measuring mental and emotional well-being. I want to point out here as well that we could also get some of our non-parametric tests. If we were running those, we could take off Kendall's and Spearman's. Those are non-parametric correlations, but for now, we're interested in the Pearson's correlation. You could also, if you go into options, you can get means and standard deviations for your variables. So I'll click OK. And we see the correlation matrix has been generated. Ideally, you are checking the correlation between two variables at a time. So for example, if I wanted to look at the correlation between age and mental and emotional well-being, I would have to look at where those two variables intersect within a cell, right? Where the cell where they intersect. I also want to point out that there is duplication in the table. So I could get the same information elsewhere. If I look at the column of age and the row of mental and emotional well-being, I will get the same information for those two variables there. So looking at for the row of age and the column of DASS 21, you would look at the p-value and you'll see that the p-value is 0.386. So that is greater than 0.05, indicating that we don't have a significant relation between our two variables. But if we did, we could go on to look at our Pearson's correlation value, which is the value on top of 0.071. That would tell us the direction of the relation and the strength of the relation. So the fact that it's a positive value means that it's a positive relation. And, you know, the closer the value is to 1, the stronger the relation. The last bit of information we get in the cell is the sample size that corresponds with N is 150. And you can do that for all the variables of interest to check the correlations between those two variables at a time. So just to show you how to read the table, and we'll talk about the write-up in more depth afterwards. And the last one that I'll tackle is multiple regression. So I'm going back into Analyze, as they would have said, you get a lot of things in the Analyze tab. So Analyze, I go into regression and linear. Remember, we're using a linear model. So Analyze regression linear. And again, I will just right click here to display variable names so that I can see my variables better. And we'll put the outcome, which is mental and emotional well-being, into the dependent box. And we're going to put our predictors into the independent box. Now, this is a standard multiple regression. So we're not doing blocks. We're not creating, any steps. This is, we're just putting all the predictors in to this box. So that would be age, COVID-19 exposure, face-to-face contact, and virtual contact. And there's a lot that we can dive into with multiple regression. For example, if we go into statistics, I could take off descriptives, and if I wanted to generate not just the means and standard deviations, but also a correlation table to assess multicollinearity, to see if I have multicollinearity, that's one of the things that you could do. All right. And there are a number of other things as well. I could go into plots and plot certain things that would help me to check for my assumptions, like homoscedasticity and those things. We could check using those values. And so you can explore and see the other things that, that you can use. So in the interest of time as well, we're just doing a basic standard multiple regression. So I click OK, and you'll see the results that have been generated. So the first table will tell you what your predictors which have been entered, and then your outcome is mental and emotional well-being. When you come down to the model summary table, you can focus on the R-squared value in particular. That will tell you how much variance your overall model has explained. So we can express that value of 0.34 as a percentage, right? And that would mean that our model, all of our predictors together, would have explained 34% of variance in mental and emotional well-being. And you'll see that in the write-up. When we come down to the ANOVA table, you'll see that our model was indeed significant because the p-value there is less than 0.05. And then the coefficients table is what will tell you about your individual predictors. So you'll look at your significance column and you'll check those p-values to see which of your predictors was significant. And for example, COVID-19 exposure, face-to-face contact, and virtual contact, all three of those were significant predictors, but age was not. For the significant predictors, you can look at the standardized beta values and interpret those like correlations. So for example, we see that COVID-19 exposure was a negative value, meaning that it had a negative relation with mental and emotional well-being. So this, and you can interpret direction and strength there. And the last thing I want to mention is in this unstandardized coefficients column is where you can get information that pertains to the multiple regression equation. Like if you wanted to insert your constant or your intercept and identify your slopes, you would find them in this column. All right. So I'm just monitoring the time here, and I think I can hand over now to Dr. Addison to take us through the group comparisons.
Okay, thank you, Ms. Brito. So let me share my screen and we shall talk about, everybody seeing my screen, right?
Yeah.
Yes.
Yes. Okay. So
Yes, yes.
So great. So what we're going to do here now is we're going to continue with the test. So as I mentioned before, we were talking about the t-test, and we're going to use similar variables as Ms. Brito used just now. So we go to analyze, compare means. In this particular case, we're going to perform an independent samples t-test. And we wanted to look at, and you will see in our summary slides, if it is that you forget the variable names, we'll have a nice write-up for you to see where we are looking at the difference. Is there a difference in the face-to-face contact or COVID-19 contact, and if you were a primary contact or not of a COVID-19 patient? So in this particular case, the test variable box, we're going to put the face-to-face contact variable. And that is actually a sort of numeric subscale, as Ms. Brito mentioned before. And then our grouping variable here is, have you been, is your COVID-19 exposure? So we could just display the variable names as Ms. Brito mentioned to make it easier. Now, you would notice when I put in the grouping variable here, it actually is prompting me with 2 question marks, because remember the t-test talks about 2 groups. So we have to define these groups here. And when you define these groups, it's actually based on, remember those numeric values that Ms. Aladdin and Ms. Samlal mentioned before. Please excuse my neighbor's dogs. There are about 10 of them. So they always come into play when I'm in meetings. So just letting you know if you're hearing them. We had 2 different groups. So we have 0 and we had 1, because we coded whether or not somebody was in contact with a COVID-19 patient with those 2 values. So those are our 2 groups. So we click continue. As I mentioned before, this is version 27. So it will have something called estimate effect sizes. This may be a little more advanced. I know my postgraduate students who have also joined they should be able to tell the undergraduates what the effect sizes are. And I think some of the undergrads would also have learned that as well. I think we have everything in there. So let me click OK. And I know I have to stop sharing and reshare the output. So let me share my output again. I trust everyone is seeing the output of the t-test.
Yep.
Yes.
So excellent. So right, so this is our output here, and to just go through it quickly, because we'll have a summary in the slides for you. You could actually see the group statistics, which is basically the descriptive statistics about what we were looking at. So we were looking at face-to-face contact segregated by if you were a primary contact of somebody who has COVID-19 within the last 6 months, yes and no. So you could say there were 90 persons who were in contact, 60 persons who were not. And then we have the means and standard deviations there. And in terms of the independent samples t-test, so this particular portion here, before you would notice you have 2 different lines, and you may be thinking, well, how do I know which of these to choose from in terms of my conclusions and my analysis? The first thing is we have to look at the Levene's test for the equality of variances. So the Levene's test gives us that homogeneity of the variances, or as I mentioned before, that assumption we needed to fill. Now, the sample sizes are quite large already, 90 and 60 persons. You could assume normality there, or you could test for it. But I'm just going to concentrate on the Levene's test here, which tells us if it is that equality of variances could be assumed. So the null hypothesis in your mind, if you want to think about it like that, would have been the variances are equal, and the alternative would have been the variances are not equal, or equality is not assumed. Based on my significance value here, which is 0.949, which is greater than 0.05. Remember, if it was less than 0.05, we would reject the null and say there is a difference in the variances. But in this case, we do not reject the null. So therefore, we could say that the equality of the variances can be assumed. And in this particular case, because I'm going with this particular conclusion for the Levene's test, I will follow along on the same row here to actually extract the t value, the degrees of freedom, and the significance value, which is the p value for the test for the equality. So you basically have in this one table the assumptions in the Levene's test, and once you actually move along from that assumption, you could actually make your conclusion for your t-test based on this particular portion here. The nice thing about the test for equality of the means here is that it's telling me now, based on that assumption, that the p-value 0.013, which is less than 0.05. In this particular case, remember, we were trying to test to see if it is that the face-to-face contact, or the mean value in terms of the face-to-face contact, there was a difference between persons who were in contact with somebody who was a primary, or who had a primary contact, and persons who did not. In this particular case, we could make that conclusion that it revealed that there was a statistically significant difference in the interhousehold contact between those primary and non-primary contacts, let's say. And then you could also mention the mean difference. It gives you the actual difference. It appears to be a small difference here based on what we have here, although the test actually told us that it's a significant difference, and there may be various reasons for that. And in terms of the confidence intervals, you could also make notes of those things as well. And I'll just jump in quickly and mention that in terms of effect sizes, the effect size is something similar to the R or the correlation value that Ms. Brito mentioned before. So for more advanced students, you could actually quote the effect sizes, in this case, the Cohen's D, which is 0.418, and they are medium, small, medium, and large effects. And it comes in very handy in terms of more advanced studies where you do meta-analysis based on previous studies and you want to know if it's a small effect or a large effect. This would actually be a medium effect. And this actually is very, it's linked to your R value. So even if you didn't have the effect size, that's okay. You could talk about the correlation value and it actually gives you the same idea. So this is the result of our t-test, and we will show you the conclusion of that test in a little while. In terms of the ANOVA test, the one-way ANOVA, we wanted to look at, in terms of analyze, compare means one-way ANOVA, we're going to look now to the socioeconomic differences or the perceived differences in terms of the mental and emotional well-being. So we're going to actually put in, let me put display variable names again. And this particular one, we have socioeconomic status as a factor, and our dependent variable here is the score that we got, this DAS score, which is our mental and emotional well-being score. And of course, as I said, in SPSS 27, you have the effect size. If you don't have it in yours, that's okay. And in terms of contrast, post hoc, now I'm going to put in post hoc one time just for you to have an idea based on what we mentioned before. And I'll click Bonferroni and the Tukey. You don't need to use both. You could actually just click one. I know a lot of you are more familiar with the Bonferroni, but I will show you both. And in terms of options, there are lots of different options here. We'll keep it a bit simpler. So just look at descriptives and any homogeneity of the variance, which is the same test that we were mentioning before. And I'll also mention a means plot so you could actually see what that means in the context of analysis of variance. So it will bring it to life for you. So this is our results. You're going to see we have a number of tables here, and we're going to have a means plot that I'll actually just talk about quickly. So the descriptives, you're very familiar with the sets of descriptives, and I'm going to mention this from now. I know when people get a number of tables, they feel like they need to use all the tables. Remember, one important thing that Mr. Aladdin mentioned to you all in segment 1 is that you cannot just use the wholesale tables. And what I also noticed is that people just put in tables and then they're not really talking about what's in the table. Sometimes the table has more information than you need. So you need to actually construct the table based on your needs in terms of what you want to explain. So the descriptives here, I would say it would be nice to talk about the fact that the differences in terms of the groups with respect to the mean values with the low to high socioeconomic groups. You could see the mean values there and you could describe where the differences lie. In terms of our purposes for the test, we see that the homogeneity of variances based on the mean, that Levine statistic, it's actually, well, the significance value there is 0.926, similar to the t-test as before. We realize that in terms of the quality of variances, we could assume we do not reject H0 because it's greater than 0.05. So I don't reject the null. So in this particular case, you assume that there is equality of variances there. In terms of the actual ANOVA, this here gives you the idea of the overall model and if the model itself is significant. So in this particular case, the overall model here is significant because it's much less than 0.05, it's 0.00. Well, it's probably something extremely small. A lot of the times in the write-up, most of the time I put less than 0.05 or 0.001, depending on the study, then you have the F value associated. So the overall ANOVA model, in fact, is actually related to the regression model that Ms. Brito mentioned, because ANOVA is the analysis of variance and regression also calculates the variances as well. So it's a similar idea in terms of the actual model generated. So here, based on the actual predictor variables that I mentioned, in terms of emotional well-being, the model is significant. So the differences there are significant. So if you just say the model is significant, I don't think that's enough for you. You need to underscore what exactly is significant in terms of the differences. So we had the different socioeconomic groups, and it was based on if you were in contact or not with a COVID-19 patient. So we actually could talk about the comparisons. Now, why I'm mentioning this is because now that I know there are significant differences, so the conclusion would have been that the mean differences, there were statistically significant mean differences within or among those groups. That's your conclusion. But then somebody may tell you, well, okay, so which groups were statistically significantly different from the others? You know, how could I tell? That's where the multiple comparisons test comes in. I'll skip these effect sizes and I'll mention that when we talk about the actual conclusion in a little bit. But the multiple comparisons based on the post hoc tests that I mentioned, we have, as I know some of you already know about the Bonferroni, so that's fine. Both of these tests will give you similar significance values. You don't have to use both. As I said, I just put in both, but you could see based on just the different groups here, you could see all of the actual differences for each of the groups were significant. And what this means is when you read this table, you look at the comparison. So you're seeing socioeconomic status I, and then you see socioeconomic status J here. And you have middle and high, and you have low outside here. And you have middle and then low and high. You would notice there would be, it might be repetition in certain senses because low and high SES and high and low SES is basically the same thing, right? But the point is, you have to talk about each pair. So you could say from this table then that low and middle income socioeconomic statuses, it was a statistically significant difference between those groups in terms of COVID-19 contact. Same thing between low and high. Sometimes you would get it being that some one of them was not significant, and that would be something key for you as a researcher to think about if there's anything else you need to do with that. This table here with respect to homogeneous, the homogeneous subsets, you could actually just disregard that for now. That is actually just something based on the groups and how they actually compute the means for the mean plots. So what would be beneficial for you actually is a visual as well, because you may want to see now, you want to tell somebody in your research work, okay, well, this is how these, because remember, the means were numeric values. So you could actually track those means for those categories of low, middle, and high income, the SES groups. And you could see the differences there very clearly in terms of those mean differences. So that is it in terms of those particular tests. I think I could probably quickly just mention to you about two-way. If you wanted to do two-way ANOVA, if you wanted to put in two different factors, you can also do so. So you could go into analyze. I don't know if we have time to go through all those results, but I could actually just scan through it so you could have an idea. Because remember, these are, as I said, these are foundational tests. So you can go into a more complex sort of idea after you build up from the initial test. So for instance, you could go to general linear model and then to univariate. And if I wanted, I could do something similar where I could put the same mental and emotional well-being there as the dependent variable. And then I could have my fixed factors as the socioeconomic status, and then have you been a primary contact? So those are the two fixed factors. There are a number of other things we could add in here now in terms of model. Let's see, contrast. So we go into plots. What I like about this is that you could see some additional plots. So I'm going to just put in the horizontal axis, let's put the COVID-19, or let's actually put the socioeconomic again. And then we could put separate lines for the COVID-19 exposures. And you could actually add these things here as you could cross them in terms of a line chart and these things. So you could actually see there are other things like error bars. So it's very customizable in terms of what you could do here. Because remember, in terms of a two-way ANOVA now, we actually move into a point where we have two factors. So we could consider what if these factors interact within each other as well. And then we have the post hoc test again. Now, I don't know yet if the post hoc test will be applicable to both. So we could actually just put in both and see. And same thing, Bonferroni or Tukey. I'll just leave the Bonferroni for now. Continue. There are also the marginal means. Marginal means meaning that the same thing like we had before with those mean, because remember it's mean differences. So you could put in the means for each of these. You'll notice it has the predictor variables and it has them together here with a little asterisk, meaning that they actually have an interaction. So as a student, you could play around with these things and see the types of data that you get, and that way you would also learn as well. So it's just quickly to show you that we can actually generate basically a similar analysis. You may see warnings here because the warning in terms of the primary contact didn't have any post hoc test, meaning that it was insignificant. So therefore, we didn't need to go on and compare anything because that actually wasn't numerical values. It was categorical. What would be useful to you to look at as well is the extension of the analysis of variance that we did before. So we had one variable before. Now you notice you have these two variables, SCS, COVID-19 exposure, and then you actually have the significance of the two crossed together. And you could see there that the p-value there for the significance of the two, if you were just looking at it and just wondering, there's no significant difference in terms of if you had those two variables interacting there, but the actual variables or the predictor variables themselves is as singular variables were significant. So this is important for if you wanted to do any further analyses. And then, of course, we have the comparisons that you could look through as we saw before. Same thing that I mentioned with multiple comparisons. The overall test itself, we could see the actual significance. The whole model is significant there. And then what I wanted to also mention to you quickly is this chart is very, very useful, especially when you have a larger study and you want to see if there are any interactions. You could just look at the chart, and if the lines were crossed, then at some point you could predict there was an interaction. In our case, you notice the lines did not cross. And you could see when I look back just now, SCS and the COVID-19 contact was not significant. So sometimes the descriptors actually lends to that idea as well. So just wanted to mention that quickly. And I know we have to go back to these slides, so I'll put you back on to Ms. Brito so we could quickly conclude based on all the different tests that we just did.
All right, thank you, Dr. Addison. So I know that for some of you, the factorial, the two-way ANOVA might seem, really complicated, but that's so as Dr. Addison would have mentioned, you want to just build up from your t-test, and you go gradually up to factorial ANOVA. All right. So we are going to put everything together now in a write-up, and so we'll see how we can turn the data into actual findings. So just some general tips for reporting your results, summarizing your data. You want to describe your data. You can use means, standard deviations, confidence intervals, etc. You want to provide your graphs and or tables. So these would be like your figures and tables where applicable, with their titles and labels in APA format. So you're not just copying, as we would have mentioned, the raw SPSS tables and pasting them into your report. You want to make sure that you design your tables and edit your tables to fit APA format. You can also describe your analysis, whatever the analysis was, whether it was correlation, chi-square, t-test, and you want to mention your variables that were involved. And you'll see this more specifically as we move along. You want to state your results. So if, for example, if you're doing t-test, you want to make sure and put in those means and standard deviations, your significance results with your degrees of freedom, p-values, effect sizes, etc. You explain your output in relation to the original hypotheses of your research. So this is very important because you want to tie your results back to your hypothesis. Remember, this is hypothesis testing that we are doing in order to build theories. So if we look at the chi-square example, the question that we asked, the research question was, is exposure to COVID-19 associated with socioeconomic status among adolescents? So remember, chi-square was a test of association, but we want to avoid causal claims. A null hypothesis for this particular question would be exposure to COVID-19 would not be associated with SCS among adolescents, whereas the proposed or the alternative hypothesis is that there would be a significant association between those two variables. And this is a snapshot of what we would have done in SPSS and the different steps, right? So where you plug in your IV in the columns, your DV in the rows, and then you tick off accordingly. And this would be the contingency table that we produced with the frequency counts that we went through, and the chi-square test statistic with the degrees of freedom and the p-value. And this is where we get our values for statistical evidence. So we saw that that p-value was 0.204, so it was greater than 0.05. So there was no significant association based on the Pearson's chi-square. There was no significant association between adolescents' exposure to COVID-19 and their socioeconomic status. And you'll see how you can report the statistical evidence for that. So what goes in brackets are the degrees of freedom that came from the table. And after the equal sign is your test statistic, your chi-square test statistic, and then your p-value. And so our hypothesis, the first hypothesis, was not met. Moving on to the correlation research question, we wanted to explore the relations that exist among age, exposure to COVID-19, inter-household contact, looking at face-to-face and virtual, and mental and emotional well-being among adolescents. So our null hypothesis would be that these variables would not be associated with adolescents' mental and emotional well-being, whereas as alternative hypotheses, and you could actually break this down into sub-hypotheses, but I just collated it as an overall hypothesis. Age and exposure to COVID-19 would have negative relations. So both of them would have a negative relation with adolescents' mental and emotional well-being, whereas the two types of inter-household contact would have positive relations with adolescents' mental and emotional well-being. So let's have a quick look at our results. So this would be where we entered all of the variables to produce the correlation matrix. And this would be the matrix that we produce. But remember, you're only checking the correlation between two variables at a time, looking to see where those variables intersect. And from the table, you will get your p-value, your correlation coefficient, and your sample size. So let's see how that was written up. Pearson's correlations were conducted to determine if those variables would be related to adolescents' mental and emotional well-being. Starting with the types of inter-household contact, both of those subscales, both of those variables had moderate positive relations with mental and emotional well-being. So for face-to-face, if you look at the correlation value, it's 0.37. And for virtual, the correlation is 0.27. So those were weak to moderate correlations there. All right, look at how the statistical evidence was given. What went in brackets was the sample size. And then, of course, you have to report your p-values. So you can see that these were significant relations and both of them were positive values. I'm talking about the value after the equal sign. Those were positive values, which meant that these were positive relations. And we could say, therefore, that more frequent contact was associated with better well-being. So these are brief results. Of course, you could expand on them and flesh them out more. But basically, because both types of inter-household contact had positive relations, then we can say for both of them, more frequent contact was associated with better well-being. In terms of exposure to COVID-19, this one had a stronger negative relation with well-being, and we can see from the correlation value of negative 0.48 that it was it seemed to be a stronger correlation there, and it was a negative value. So adolescents who were a primary contact, so for this variable, the higher code, which would be those who were a primary contact, they were associated with decreased mental and emotional well-being. All right, a negative relation there. The higher code associated with decreased mental and emotional well-being, whereas age was not related to well-being. And you can see from the p-value of age, it was 0.386, greater than 0.05. So overall, the hypothesis, it was mostly met, right? I think only with respect to age did we find non-significant results. Moving on to our example for regression. So we want to see if age, exposure to COVID-19 and inter-household contact would predict mental and emotional well-being among adolescents. So the null hypothesis would be that these variables would not predict well-being. Whereas with the alternative hypothesis is that these variables would significantly predict mental and emotional well-being. And we could even flesh out that alternative hypothesis more by specifying the kind of predictive relations we expect between the predictors, between each predictor and the outcome. So we can make this a directional or directional hypotheses. So these were the SPSS steps that we did. On the left-hand side, you see your outcome plugged in there and then your predictors. And then you'll see on the right-hand side, the results that were produced. And remember, I highlighted R squared of 0.34 when you round it off to 2 decimal places. And I want you to focus on the ANOVA table. You'll see that I get my degrees of freedom 4 and 145 there. Look at the F ratio as well, 18.60, and the p-value. And in terms of the individual predictors, I'll be reporting the standardized coefficients betas there, the t-values and the p-values for those predictors. So let's have a look at that. So a multiple regression was conducted to determine if these variables would predict mental and emotional well-being among adolescents. And we start with the R squared. The overall model explained 34% of variance in well-being. And so you see the statistical evidence there, right? R squared is equal to 0.34, and then F in italics there you can put your, well, this would be APA style, right? It would differ depending on the writing style that you're using. You're putting your first and second degrees of freedom. That would be the model and error degrees of freedom. Then your F ratio and your p-value. Both types of inter-household contact and exposure to COVID-19 were significant predictors. So now we're going to talk about the individual predictors. So we can interpret standardized beta values like correlations. So that's why you're seeing face-to-face and virtual contact. They had weak positive relations with well-being. So if you look at face-to-face, the beta value is 0.23. And if you look at virtual, the beta value is 0.18. You look at the p-values, both p-values were less than 0.05. So again, those beta values there would indicate that they were positive relations, right? And the p-values being less than 0.05 indicate significant relations. So how can we discuss that? We can say more frequent inter-household contact was associated with higher mental and emotional well-being. Exposure to COVID-19 had a stronger negative relation with well-being. So we can see the beta value there is a negative value and the p-value is less than 0.05. As such, adolescents who were exposed to COVID-19 were related to worse mental and emotional well-being. So just like what we saw with the correlation results. Age, however, did not predict well-being. And if you look at the p-value, you'll see that it's greater than 0.05. So the hypothesis overall was mostly met. Again, with age is where we saw that it was not a significant predictor. So at this point, I'll hand over to Dr. Addison.
Okay, thank you, Ms. Brito. So we'll just continue along the same trend with the t-test. So I'll just give you a quick summary in terms of those results. Remember, we were looking at the difference in the face-to-face inter-household contact based on whether the adolescents were primary contact of someone diagnosed with COVID-19 or not. So those null and proposed hypotheses were based on that original question. One thing I would like you to note is that you can take the stance of either the null or the proposed, because sometimes people are confused about which is the null, which is the alternative or proposed, and which stance do I take. So in this particular case, we just highlighting a general idea of what we thought might have happened. So we said that the adolescents were a primary contact of somebody who had COVID-19, they would have less face-to-face inter-household contact than those who were not. And we were trying to test that using the t-test. Next slide. And these are just the snapshots. So Ms. Brito, you could go past these snapshots since we did these already. I just wanted to point out though, just for reference, that before you even do the t-test, if you were thinking about the question, you want to kind of visualize how the data looked for that question, you could actually do a graph. So this is a simple graph we generated within the chart builder there, just a simple with the counts on the y-axis, and then on the x-axis we had the primary contacts by no and yes. But what we did was we categorized those counts in terms of the face-to-face contact. So you could see the numbers in terms of the face-to-face contact, and I'll remind you, for your purposes, you could have grouped this or categorized these numbers even more. You could have probably put less than 8 times, greater than 9, that sort of thing, and have the categories smaller. For these purposes, you could notice that the groups with the less, who answered yes, they were the majority of the count in terms of these particular graphs. So we disaggregated them in terms of the household contact. And we saw that in terms of the numbers 60 and 90, as we had seen before. Next slide. Right, this is also another supporting figure. So I'm encouraging you all to use visualizations before you just jump into the actual test. So for instance, this figure, and just to note, we wrote these results in terms of the APA style format. I know Chicago Manual of Style may differ a little bit, so you all would have to make sure you understand the formats for your particular courses. And this is a simple bar graph here, which actually gives you the mean face-to-face contact with respect to the people who answered no and the people who answered yes in terms of their primary contacts. And we could have seen here that it was actually less for those who were primary contacts than for non-primary contacts. And we have the means and the standard deviation. So please be very descriptive with your data when you're actually doing your results. Next slide. So in terms of the t-test results, I'll summarize. Remember, we spoke about this before from the actual results, but you're now actually seeing it in a tangible format. And the mean difference in the contact was less for those who were primary contacts of COVID-19 patients than for non-primary contacts. And I also mentioned the independence and normality assumptions were met. We know from the Levine's test, the assumption of equality of variances was also met. And the t-test itself said that there appeared to be, and I use the word appeared to be, a statistically significant difference in the inter-household contact between primary and non-primary persons. The reason why I use the word appeared is because sometimes people would say, but it doesn't look like a very vast difference when I looked at the means and the standard deviations, but the actual test gave me that result. Remember, these tests are contingent on the size of your samples and different things. So don't assume, and I will go back to the idea of correlation and causation. Correlation isn't causation. So even if the test said it's statistically significant, it may not necessarily always be practically significant. So you could always keep those things in mind. So for your purposes, for you to not get overwhelmed, remember, you are just reporting based on the sample sizes that you actually put into the software. Next slide. And the one-way ANOVA, remember, we just looked at that one with the socioeconomic differences in the mental and emotional well-being of the adolescents. So we had the 3 different groups. And our proposed hypothesis here was if there was a significant difference in terms of the mental and emotional well-being for those particular groups. Next slide. So we have the snapshots. So we could go past those snapshots since we already know where we were deriving that information from. We have all the different snapshots. Remember, this is the raw data that you would have been working with, the raw results. And now we're going to make this into our story, which we would actually be able to use. Yes, and this is one of the means plots as well. So the results here, everything is summed up just as I mentioned, what I said verbally before, but you could see it now as again in a more tangible format. The first paragraph, I'm talking about the mean differences in the different groups by socioeconomic status, and I mentioned the means for all the different groups. And you could actually see I gave a comparison. Please be very descriptive, very comparative, use measurable words. So for instance, the mean was, it was actually higher, and I could probably even go further to say it was slightly higher in terms of, if I were to mention the middle group, which I didn't mention here, you could talk about the middle group as well. I spoke about low and high and their means and standard deviations, and I spoke about the assumptions. Then in terms of the one-way ANOVA test, I mentioned the Levine's assumption was met. And then I also mentioned the statistically significant differences in the actual categorizations. I went a step further to mention this eta value. If you see on the last line above post hoc Tukey test, you'd see that eta squared value. That's an effect size. So some of you who may not know, it's basically, as I mentioned before, something to give you a tangible idea of, like, for instance, how correlations give you that strength of linear relationships. This is giving you the size of the effect in terms of these predictive variables and their effect on the actual, the outcome or dependent variable. And in this case, it was a small effect. There's a table that goes with it as well. So you could actually be able to look through the table and see what those values are. The last few lines, sorry, well, actually, that's okay. The last few lines, I was just basically outlining the multiple comparison test, and it was a statistically significant difference for all the different pairs. And we expected that because, I mean, low, medium, and high income, or low, middle, and high income would have differences in terms of their mental and emotional well-being, which is something you could do in your discussion to go further. Next slide. So I just wanted to point out some references that are really useful, especially for people doing APA. In terms of the tables, you could check these links. APA-style.apa.org, that's the official APA website. It has a really, really nice page with different tables for like correlations, different tables for ANOVA, t-test, and the actual format that you should use when you're extracting from SPSS. And of course, Dr. Andy Field's book, Discovering Statistics, he has a nice document online about writing lab reports, which is basically pulling it together with all the, from abstract to discussion and conclusions. So you could actually feel free to look at those. So we have come to the end of the actual segments now. So we would invite you all in the last few minutes that we have before we end to do two things for us. Let us know what questions you have and fill out the survey, which Ms. Aladdin and Ms. Samlal will post for you now. This is a post survey. So this is not the original survey that you were looking at before. This is not the icebreaker. This is a survey based on the actual segments that we had today. So we would like you all to start filling that out, and we are opening up the lines for any questions. We are free to answer your questions now. So does anybody have any questions?
Sorry, if I may just add quickly that the write-ups that you'll see may not look exactly the same as to what you're accustomed to, because remember, there are different writing styles and so on, all right? But the information you will see is more or less the same in terms of reporting your analysis and then your means and standard deviations and so on. So I just wanted to mention that.
Right, excellent point, Ms. Brito, in terms of your manual, the style and these types of things, and there are little nuances here and there, but I think we are, so let's see. Right, so someone asked about accessing the recording. So it will be posted on, we will, with permission from the head of department, we will see if we can post that on the Behavioral Sciences website. Are there any questions? I think there were some questions initially. So Keisha and Farina could let us know what questions you all had based on the original set of questions in the chat. So we could just address those to anybody who needs to be educated on that.
Okay, so there was one question asking about omitting the zero as a value, and how important is it not to make this an error? So I believe they're referring to including zero as an option in the questionnaires itself.
Omitting zero as a value.
Yes.
Karina, you want to take that one? That was based on the first segment?
Yes.
Yep, I think it's based on the levels of measurement. So if the person who is here who posted the question, if you're not satisfied with how we respond, you could always clarify exactly what you mean. So the zero value has to do with your ratio level of measurement. So as Ms. Amma would have said, if you ask people a question where zero is a meaningful value, like the question on the icebreaker survey, how many stats courses have you done? If you did no courses, then zero is a value. It's a meaningful value, meaning you never did any statistics courses. Or like, how many times have you experienced anxiety over the last week? And if you have 0 times, that means zero is a meaningful value in that terms. So it depends on what you're measuring and how you're trying to get the information. So it's not really about if it's an error or not. It's really how you have come back to defining your variable and if you need that meaningful 0 point. And in most cases, once the variable itself has a meaningful 0 point, it's better for you to try to capture that data than to start at an interval without the 0 point, because you want to leave as many options for anybody who is answering the question that they could find a box to tick as their response. I'm not sure if that answered your question fully. If not, you could always unmute and clarify in the chat.
I could also add to that, based on experience, sometimes people would wonder, like for instance, labeling, should I label something 1 or 2 or 0, 1, does it matter? Generally, it would not matter. Like, for instance, a lot of the times with gender, people wonder, could I label male and female 1 or 201? Let me give you an example from a context of, like, for instance, as Ms. Alana mentioned, how meaningful it is. So, for instance, in terms of building like a student retention model, I could say retain is 1 and I could say not retain is 2 and that sort of thing. But for me, for my purposes, and especially in building like a logistic regression or even just a general regression model, having not retain as 0 and then retain as 1, or depending, you could switch it around, it actually gives more meaning to me as a researcher in the end when I get my results, because it kind of quantifies in terms of who wasn't retained. And I'm telling you, from an actual model, it really makes it easier, because sometimes it gets a little confusing when you have these 1s and 2s, even though you know the words. So the whole thing about it is really and truly, you're at a point where you could make it, you could actually customize it to your needs, but sometimes little tricks that you would learn as you use the software more would help you in terms of doing your analysis. And that's why it's so important when you all learn, especially in the undergrad courses with all our very esteemed instructors that we had today, that you really try to use the software, because they have given a lot of guidance in terms of the practical aspects, showing the demos and that sort of thing, but really use the software and practice it. Don't get overwhelmed, don't get scared, just go into it, just play around with it, make mistakes, that's fine. And that's where you will pick up things, you know, little things here and there to help you when you actually get to using it on your own. Anybody has any question that they want to ask over the mic, or any other questions that we had from the previous segments, or from Ms. Brito's segment? Sorry, Kish, Ms. Hamlal, you could let me know if there were any other questions before we talk about our segment.
There was an additional question, and I think it could be answered from presenters in both sessions. So someone asked about interpretation and reporting of outputs, that sometimes it's a lot of tables and they feel overwhelmed. So which tables and which graphs would be most useful for that reporting of the data?
That's an excellent question. Anybody wants to go first, and I'll jump in after?
Let me start from the descriptive side. So tying it with the tables and stuff. So the first thing would be that you need to make sure that you actually know what analysis you want SPSS to do. Because as we showed you, and as the second segment showed you, it can do anything that you want to do. So you need to first of all make sure that you're not doing unnecessary analysis. So if you needed to do a correlation, then there's no need for you to be sending in the request for it to do a NOVA and chi-square and all of that. So that's one way to not get overwhelmed, to make sure that you're actually asking it or programming it to do the analysis that you actually need, and not just because a whole list of things comes up that you do everything. And that will tie back to what Ms. Samuel said at the start, grounding it in the literature review and your theory, your hypotheses, your research questions, and your research objectives. So you're not doing unnecessary analysis, which is where part of the overwhelming feeling comes in, because you didn't know what you were looking for in the first place. So you just say, I'm going to tell SPSS to do everything, and then I'm going to hope that I could figure out what it's saying. Right? That's a wrong side way of doing research, which a lot of students do because they just want to make sure they cover all of their bases. The safer way and the less overwhelming way is to make sure you actually know what you're looking for. So SPSS gives you exactly what you're looking for. And then in some cases, it does give you extra outputs. And that's where you have to sift through and determine exactly what out of all of these tables do I actually need. And I think Dr. Addison will be able to explain that more, because most of that extra output really comes out with the inferential analysis than the descriptive.
I don't know if anybody else wants to jump in before I jump in.
Yes, I just wanted to add that as a student, I found the textbook really helpful to me. The Andy Phil textbook is what we use in our course. I found that helpful in terms of the practical steps of, you know, step one, you look at this table, the ANOVA table, and then the pairwise comparisons table. You know, it's a really useful resource, and I really want to emphasize it because it helped me as a student. And so I would want to pass that on to you all, that resource can really not just in terms of the SPSS steps and what to interpret, but why you are looking at the ANOVA table first and then the pairwise comparisons and so on. So I just want to mention that as well.
Excellent point. Ms. Samlal, anything to jump in? Okay. So I will say I understand the sentiment of feeling overwhelmed, especially when, as Ms. Aladdin said, if you're not too sure. What I usually do is I would say, and just from from a consultant aspect, sometimes people have these very, very broad things they want to do. If you start out with something extremely broad, you're going to overwhelm yourselves because you don't have a refined view as to, and I always tell people, try to refine to at least 3. Now, I don't know how it is for your specific courses, so I'm just giving you advice, but of course, it's customizable. At least 3 research questions, 2 or 3 main research questions that you really think you want to answer, because you will start off with something broad. And remember what we're trying to do, we starting at a broad level and we're trying to get this more refined. From those research questions, make sure you have something that you could measure. If you have something very abstract, like say hunger, something with anxiety and hunger, how are you measuring hunger? You're going to have to figure out how to do these things in a measurable sense. Remember, the software, as Ms. Aladdin had mentioned before, it's going to kind of convert your ideas into numbers then, because it's like math behind this whole window, right? So I would say one of the things you need to, first of all, is sit down and think about what you want to measure. And of course, you'll come up with your hypotheses. It may not be perfect. Don't aim for perfection in the beginning. And I think that's where you'll get overwhelmed. Just start off. Have these very simple questions about what it is you want to answer based on what you know. Don't go fancy. Don't go jumping into things yet until you figure out, okay, this is what I want to get. So I'm doing this survey as we had seen before, came up with the questions for the survey. Please make sure that you really review the survey questions and make sure that the questions are not redundant and these things, because that is going to make your life worse when you get to the point of analysis. But what I can say is when you actually reach the point of you have the questions you want to actually study and say, okay, now I'm going to do some sort of analysis here. Where do I begin? Always begin with your descriptives. That's why we did it in segments. So you have to see the flow. Start with the descriptives. And what happens there usually is you would see when you do all these different tables based on the variables. So you need to think about the variable type and then the kind of graph. If it's numerical, do we want a histogram of the ages? If it's categorical, do we want the frequencies? Do we want to cross it with something else? Throw everything but the kitchen sink or the kitchen sink itself, everything into one, and just try to figure out, okay, if I do all these things, is there something looking on this graph? Does this look like something that I could study further? And that kind of propels you into what sort of analysis you want to do, especially. So that's why people don't realize how important descriptive statistics are. And from that point now, you could refine. So I'm telling you, you will get overwhelmed at some point. That's a given because of the stage that you're at, and that's okay. Just make sure that you kind of ground yourself in the fact that you know how to use the software, and just you have to actually say, well, okay, let me refine. So it's a bit of a refining process as you consistently go along. So by the time you finish your descriptives now, you look at your graphs. Is there something else I could see here? You may see another hypothesis come out of something else that you were originally doing, and that is how you grow without just only looking at the literature out there. So the literature out there would guide you. So that's where you have to start as well. And once you have those variables and you have an idea, these are the things I want to look at, really and truly, to just sum up what really overwhelms people with the tests is not knowing the type of variable on which tests. And I think that's where you'll need to really, just as Ms. Brito mentioned, in the actual Dr. Ali Fieldbook, and even online, you have a lot of resources to remind you of which tests to use based on which variables you have. And once you get into the hang of it, remember, you wouldn't get that overnight, but it's really something you have to stick with, because my background is math and stats, and I'm telling you, you can't just read slides. You really just have to sit down and go through these things. All of our instructors could tell you at the level of masters and PhD, you have to sit down and really just be, going back and forth with data, and that's how you learn as well. So I would impress that upon all of you to be able to, do that portion. And in terms of your write-up, when you get to the write-up now, start with your descriptives, build a story. We are building a story about what we actually found. So we start with the descriptives, and then we cascade through the tests now, and we pull out all the significant parts of it. Don't keep thinking in your mind, because the study had this significant, mine must have this significant also. I think that's what kind of overwhelms people as well. You just focus on your study, and then you could compare the differences, limitations, and all these sorts of things, right? So I just want to impress upon you all, if you are overwhelmed, that's okay, but don't stay in that place. Just, I'm hoping that this would have actually helped you all to actually come to a point where you could see where you are. You have an excellent base right now in terms of all the instructors. Feel free to ask them a lot of questions, and just know that from here, it's just you as a student now have to keep building on that base. There's nothing else they could do aside from giving you that grounding. And of course, we are all here to answer questions, both at the undergraduate and postgraduate levels as well, right? Are there any other questions or speakers? Anybody else wants to jump in and add anything for
I saw a question in the chat.
Yeah.
So it's, how is the theory tied in with the hypothesis findings?
How is the theory? Right. So that part of it, well, I mean, each of us could probably give you a little bit of notion on that. I would say, remember, oh, you mean this particular test, or you mean in general? I don't know if that person could specify.
I think it's in general, just generally
general?
after you get your findings, how do you tie it back to the theory
Right.
that you would have used?
And then that would have been in your discussion. So remember, in your results, you report and what the results have. So you're not going to go into a whole set of theories in your results. In your discussion, it's a flow. Remember, it's a story we're telling. So you go and you sat down, you did all of this thing, then you came to these results. This is what I got. And then in the discussion, you tie it to say, well, this was in agreement with this person's study, or it was not in agreement with this person's study. This person used this other variable as a confounding factor in this approach. A further study in my work could be, I could include this factor, that sort of thing. So you have to tie it into your discussion after you get your results. I hope that answers your question. And I don't know if anybody else wants to jump in, Farina, Delia, Keisha, and say from your experience what else we could talk about.
Yes, just to add as well, you know, when you get your results, you can determine if their findings refute or if they support the theoretical tenets and what you would have seen in the literature. So, for example, previous literature may have not found a gender difference, but maybe you did, and so you can expand upon that and speculate, drawing on other literature and other theories as to why maybe you found a gender difference and so on. So that's how you can take your results now and tie it back to the theoretical concepts and principles, as well as findings from other studies that would have examined those theoretical concepts as well.
Yes, and I just wanted to add, you know, this is where your skill of writing comes in. So sometimes we get so bogged down with numbers around statistics that we forget that essentially we need to be good writers as well. So when you're connecting it back to your theory, you're saying, you know, whether you're finding support or, you know, kind of like conflict with what the theory may have proposed, but you're also bringing in things like context, you know, being very specific to your study itself, and you're trying to then build on that to either add to the theory in a way that you're saying, well, this challenges it, or it adds to it, and maybe we could take some contextual information into consideration here as well.
Someone asked if qualitative research limited in general findings that concerns generated data. Anybody wants to take that question?
So, okay, so I'm actually a qualitative researcher. So with qualitative research, you're not really aiming to generalize. It's very exploratory in nature. And with qualitative research, you're not trying to just think of what you found for your participants and apply it to every other person who could qualify as a participant. It's never that. You're trying to get depth with the research. You're trying to understand this particular issue or problem, and find as much as you can about that issue or problem. So with qualitative research, it's very different. That's probably the last thing you're thinking about, generalizability. You're more trying to find out more about the problem. I wouldn't even say population, the people who are involved around that problem. You want to find out as much as you possibly can around it. And you're not just aimed at finding out about the similarities, but the differences that could be experienced around a particular problem is very much important as well. So qualitative research tends to be very different to quantitative research, but they complement each other in some ways. I don't know if anybody else would like to add anything.
Absolutely. You said that perfectly. Yeah. And I mean, I feel like in this day and age as well, and as Dr. Esnad mentioned in the beginning, it really is a movement between both. Because a lot of the times with that qualitative research now, you may be able to think of a study you could do that's a little more quantitative in nature, as Ms. Samuel mentioned, to support those findings as well. So, you know, think outside the box. And you all have the tools now. You all have the background with respect to the writing as well. And now you have the quantitative aspect.
And just to add, it's not a limitation. So I know the question said if it's limited, it's not limited in general findings. The aim is not to have these broad general findings. You want to go in-depth. If you want general findings, then you take the quantitative approach. And if you want both the in-depth, the context, which will be the qualitative, and the content, which will be the broadness, then you do the quantitative and you combine it intermix. So there's no, this idea of a limitation. Some research is designed in a particular way, and you choose the research and you do the research depending on what story you want to tell. And a qualitative researcher could still use the descriptive statistics. You could still show how many people were in your study. You most likely wouldn't be able to go as far as the inferential, but that's not where qualitative research is designed to take you in any case.
And I just wanted to add, as Ms. Aladdin said there, it's always about telling a story. So just to sum up everything that we have really spoken about today is really to get you from that point of just doing topic by topic and just seeing topics being done to really propelling you now into that idea of being storytellers. Because for me, personally, one of my mantras is using data to tell a story is really at the heart of who I am. And as we really wanted to impress that upon you all as well, to really just get into that aspect of it, to not overwhelm yourselves. Remember, you all have the writing skills. I would say you all have the better writing skills than the statisticians. So you all at that point where you could now take that and, as I said, marry that with the quantitative and really make it something very, very meaningful to your field. Any last words or questions before we close?
Before we end, or before we just take any last questions, I'm just going to briefly share my screen and show you all the students where you all can access SPSS, because some people are saying they want to practice and so on. So UWI actually provides you all with SPSS free as students. And now that we've moved to a virtual space, they allow you all to be able to download it to your computer. So if you go to, so let me find it.
And right while she's doing that, what I want to mention, if you get any trouble, because I know I had some students get in some trouble with the license, please contact the tech person from SIP, or I could also advise that on SPSS website itself, there's a trial version for a month in the version 28. So you could try that if you get any trouble, but please try to access UWI's zone first. And if any trouble, you could feel free to use that month-long trial version from SPSS. Just Google SPSS, IBM SPSS, and trial version, and it will come up. You could try that. And Farina will show you all the place, right?
Right. So once you go to your student portal, so the my.uwi.edu, you put in your student ID number and your password. Right. So you'll see all of these links here. So we have home, email, e-learning, secure area. You go to my documents. So we usually don't touch these unless we need them, but my documents is where you should go to. And these are all of the programs that UWI is licensed to be able to offer us as students, that you're paying to be able to be offered. So you go through, you have SPSS here, and it has the document that will give you the license to be able to download it. And it's an annual thing. So every year you're provided with this. Once you download it, you will have it accessible on your computer, whatever it is you're using. For a year, then it will expire and they will update it again, and you'll be able to download the new version. So the SPSS license itself just lasts for a year. So once you download it, you have it for a year, and once it expires, you just download it again. Or you go back to the same My Documents and it will be a newer version of it. This is also where you could find other software if you felt like you needed to use other softwares like MATLAB and Minitab, which other students might use, but in the social sciences, behavioral sciences, we mostly use SPSS, which you could access through here. And then, as Dr. Addison said, if that isn't working, then you could choose the free trial version.
Great. So thank you so much, Ms. Aladdin. Anybody else before we close? I'm not seeing any other questions in the chat, except I know someone mentioned about if we have any upcoming sessions. The department will advise on any upcoming other workshops that are being offered in terms of this area. And I would just like to thank all our speakers for this session today, our instructors and assistant lecturers and lecturers, everybody who came out to actually make this session a fruitful one. To our tech person as well, Mr. Nigel Jack, thank you very much. Ms. Dr. Esnad, for being here as well and for giving us these the opening remarks. And of course, we could not do this without our student body. And for all of you participating on a Saturday morning from 10 till 1, thank you so much for giving us your time and for allowing us to help you help yourselves. We really have enjoyed it, and we look forward to hosting other sessions like this in the future. So if you all please fill out the survey before you go, and do enjoy the rest of your day and be safe. Any last words from our speakers? I think we all had a really great time with this session with you.
Yes, I think you said it all. Thank you to everyone. Thank you to you, Dr. Addison, as well, and to all my co-presenters. It was a great session.
I agree. So thank you all, everyone, for your attendance. Thank you for your time today.
Yeah, thank you, everyone. I will see you all hopefully at other sessions I will be having under the BSSC.
Yes, definitely. Great. So you all enjoy the rest of your day. Stay safe. And take care.
Great. So you all enjoy the rest of the day. Stay safe.